actually, is there another mic in case?
Is that usually? No, it's not here. It's not going to be up there.
Do you want to hold it? Do you want to hold on to it? He couldn't make it, sadly. Because he started his new job at Salesforce recently. So.
Oh, okay.
Yeah. I've got this thing in my mouth now. Yeah. I've been losing my voice a bit, so I've got a lozenge, but now I can't really talk with it.
Oh.
All right, come on in. We're about to start. How exciting. What a room of wonderful smiling faces. I'm Hugo Bowne-Anderson. I just want to thank SciPy for being SciPy and for bringing me back after all the trouble I've caused here over the years. But I really mean, this is my favorite conference, and it's where so much of the work I'm able to do and people I work with are able to do is built upon like the SciPy community and PyData ecosystem. So it's always incredible to come here. So I'm Hugo. My background is actually in math, biophysics, so biology, chemistry, systems biology. I'm doing applied math for cytoskeletal dynamics, actually, the railway tracks of the cell, microtubules in particular. I left academia, went to the dark side to work in data science, product, online education, these types of things, and continue to do so. And now I still essentially work as a data scientist, helping people, teaching people to build data-powered products. We now call them, well, first they were data, then it was ML, now it's AI. But it's data all the way down. The models are slightly different. The foundation models are incredibly powerful. So, but I do want to, that's one of the reasons I love coming and giving these types of workshops at SciPy. I'm trying to help people put the data and the science back into this type of software. And that's what we're here to do today. My colleague and friend Stefan Krawczyk, who was going to be my co-instructor, who I've developed this material with, can't make it today. He's recently started a new job at Salesforce working on agent infrastructure there. So he's very busy with that, but I have something perhaps even more special. I have Eric Ma as my teaching assistant today. So put your hands together for the one, the only Eric Ma. So Eric, maybe you can just say a few things about yourself.
Yeah, I'm Eric. I've been at the SciPy conference for a while, known Hugo for a long time. Happy to be here. Main star of the show is Hugo. If you need help, just raise your hands. I'll walk around and try to cosplay his brain.
Fantastic. So I'd just love to get a sense of who's in the room. Who works in basic science research? Nice. Who works in like builds and ships software? Great. Who's built like data-powered products, whatever that may mean? Machine learning-powered products? And how about LLM-powered products? Interesting. So what we'll discover today is that if you've worked on data-powered products or ML-powered products, the mindset isn't that different to what we need to be doing now. So in the Slack channel, which I'd ask you all to join, we have the GitHub repository, and we'll go there soon. But I do want to, by way of introduction, just go through some slides. Okay? So essentially, we've called this tutorial Building LLM-Powered Applications for Data Scientists and Software Engineers, which it is, but we could also call it, many things. And one thing I like to call it now is the foundations of LLM software and evaluation-driven development. So you may have heard this term evals float around, which is how do we like robustly evaluate our LLM-powered software. I don't like to call it evals. I like to call it making sure your product does what you think it does. And I think it's incredibly important to recognize that that's kind of the stage we're at in the space. We have a lot of demoitis, and we end up in proof of concept purgatory all the time. So I created this figure in order to just demonstrate the state of the space we live in, where with traditional software, excitement is minimal at the start, right? And as you build over time, you'll have a hello world, then add unit tests, then you'll scale and optimize, then load balance, and it gets more and more exciting over time. Now, generative AI software development is the inverse of this. You start with a flashy demo, and it's like, wow, that's cool. And then suddenly, you're like, hey, wait, does it do what I think it does? And then you go in a bit more, and you're like, wait, what are these hallucinations? And then you discover, I can't see what prompt, whatever framework I'm using is sending to the LLM, and I have no robust way to monitor my outputs and what's happening at all the intermediary steps. And then you can't even integrate it into your software stack, your pre-existing software stack. So what we see is excitement as a function of time decreasing. Now, I usually don't show this figure to such a scientific crowd, so I apologize for two things: the lack of units on my axes, and then some people might even complain, how do you measure excitement? We can call it dopamine and measure that somehow. I don't know how people measure dopamine, but surely there's some test one can do. So what's our way out? And it is really thinking through what we call an evaluation-driven development, and it's building an iterative loop where we build, monitor, evaluate, and improve, and iterate on this process. And we can even start thinking about evaluation, not too much, but a bit before real users exist. And this is one of the wonderful things about LLMs. We can generate synthetic user data and then test out how our system would respond with respect to that, right? And of course, once we get real users in, we need to make sure there isn't too much drift from what we expected, or iterate accordingly. And these are the types of things we're building today and working towards. So, for example, and this isn't only with synthetic user data, but what you can do is you have your MVP, you have some AI system, a minimal system, you have synthetic user queries, you put the queries in, look at the responses, and you label the responses by hand, okay? After this, you use your labeled data to build a basic evaluation harness. So this will be a test set, and then LLM as a judge, or testing other things like structured output and string matching. You don't need to use an LLM as a judge for all of this. And then we use this minimum viable evaluation to evaluate and improve the MVP. Now, I don't need to say this to this crowd, I don't think, but you'd be shocked how many times I tell people to label some responses by hand, and their response is, can I get an agent to do that? And that belies several things to me. But the most challenging thing for me is you can't teach curiosity. And if someone doesn't want to look at the data that their system's producing and see what's up, that's actually a very challenging thing to communicate. And that's one of the reasons I love coming and talking about such things to a crowd which is deeply interested in discovery and data. Now, as I hinted at before, I just want to say this isn't new. We've been doing this in machine learning for years, right? Where you have an MVP, collect data, label responses by hand, use labeled data to build a basic eval system, it's a test set, and then iterate on that. So I just want to say, when we're evaluating and building LLMs versus traditional ML, in ML we can collect real-world examples, label outputs by hand, train model and label data, evaluate on held-out data set, iterate based on performance. With LLMs, we can synthesize realistic queries from personas pre-launch, and then collect data once it's launched, label outputs by hand, prompt the model, tune the system setup, and then evaluate using a minimum viable eval, so test set and auto eval, and then iterate based on performance. Now, both workflows, modulo details are grounded in test sets, iteration, and failure analysis. And these are the three most important things. So, what are we going to do today? First, I'm going to take you into LLM proof of concept purgatory. We're going to build a basic app that is great in a lot of ways, but you really can't escape the challenges involved there. Then we're going to talk about the first principles for LLM software development. Then we're going to go from vibes to evaluation and thinking about why structured evaluation matters. And then we'll talk about tool use and agentic workflows. So first, for proof of concept purgatory, this is what we're going to build initially. It's a 5-line RAG system. It's Llama Index's, infamous 5-line quick start, where we can put in a query based on some data and get out a response immediately in 5 lines, okay? Then we're going to add a UI with 7 lines of Gradio code, and we'll go through this code a bit more in a second. And what we'll see is something like this, where, I don't know if you can see, I wonder what I'm going to type here. It's probably who is this? So, yeah, we're going to build a basic interface where you can drag and drop a PDF. And this is my LinkedIn profile. Say, who is Hugo? Okay, Hugo is a data, blah, blah, blah. Looks good to me. And then I'm just going to, there's no one called John in my LinkedIn profile. So I thought to see who is John, to see if it would say, I don't have enough context for this. And you can see Hugo Bowne-Anderson hired the company's first content developer, Yashis Roy, who later led the content team. So it's just hallucinating. Now, although it's not quite, that is true. I don't think it's in my LinkedIn profile, but something whack has happened there. So these are the types of challenges we're going to see. And one of the big challenges with these types of frameworks are you can't even see what prompt is sent to the system necessarily. When I put in who is Hugo, I'm not even sure what's being sent to the API, to be honest. And so there's some sort of system prompt being sent that's added to my query, okay? Now, I do want to say this is a basic example of a RAG system. Who's familiar with RAG? Cool. For those not familiar, it's information retrieval. Okay, so you've got a corpus of documents, and we're figuring out some way to retrieve information, and then we give that information plus the query to the LLM and say, answer this question with this context, this information, right? Now, the way RAG works essentially is it chunks up all of your information and embeds it in, it's essentially, embeddings of some sort in some high-dimensional mathematical space. Then with the query, it embeds the query and then sees the ones that are closest to it. So it tries to get some sort of quote-unquote semantic similarity, depending on what your embeddings are. But the point is that we chunk it, we put it in embeddings, we have retrieved chunks and use them to generate the response. Now, the Llama index code, and my intention isn't to cast shade on Llama Index at all. They do a wonderful job in a lot of ways, and I could have chosen any framework here. But the intention is to show that we can get a great demo working that abstracts over all of these things and not know then how to change all the aspects we need to iterate. Okay? Now, in the second half of this workshop, we'll talk more about agents, tool use, augmented LLMs, and LLM workflows. I do want to say first, though, I think these will be, using tools and taking actions will be some of the ways that most value is delivered by large language models. If you just think about the fact that conversations don't scale, and the upper limit of the amount of value a conversation with an LLM can deliver is like upper bounded by human time, right? So having automated systems will be incredibly important. So one thing we'll be looking through here is an app that consumes LinkedIn profiles, finds relevant candidates for a position, and automates emails to them. I don't suggest anyone build this, and I might change this example at one point, because who needs more recruitment emails? But it's an interesting case study because it shows us thinking through how to get structured output from LinkedIn profiles and then generating text. I do want to say just a little bit about evaluating such a system. So even when people do start thinking about evals and evaluation, a lot of the time it's at a micro LLM call, right? So in this example where let's say you have a multi-step process where you ingest a LinkedIn profile, generate structured output, such as a JSON, whatever it may be. As a function of that JSON, then you generate an email, right? Now, a lot of engineers will focus on, is the structured output correct? And I think that it's super important to do that. People will focus on, do the emails generated resemble the emails that were previously sent by the domain expert? Also, super important. Don't get me wrong. And getting a domain expert in the loop, who would have thought could be slightly useful at that point. But what we really want to know is, do the emails result in hiring good candidates more efficiently than the previous system we had, right? And so we do really want to think about evaluation at a macro system level and not just at a micro LLM call. So I do encourage everyone to keep their eye on that prize. So then, when we have a system like this, how do we evaluate it when I don't even know what the prompt was that was sent to the LLM? How can I give feedback on system performance? It's not clear. How can I see the data and traces and conversations of what's happening? It's still not clear at this point. And how can we iterate quickly on this MVP? So these are the types of things we'll be learning today after getting into proof of concept purgatory. So with that having been said, maybe we do jump in. I was thinking of diving. No, I'm actually going to talk a bit about first principles first to really set the stage, and then we'll jump into code. So let's have a think about what we're doing in this system. We have upstream some sort of prompt, which is what we write and whatever the framework is doing. We have some context, which is retrieved from the documents, our PDF, whatever it is, send it to the LLM, and then downstream we get an LLM output, right? So what are the important things happening here? First is we're generally doing API calls, right? Where we have an input, an output, we have system prompts, we have user prompts, we have context, perhaps structured output. We have knobs we can turn, such as temperature and top P, which we'll get to. LLMs are non-deterministic. I mean this in several ways, right? So same input can get different outputs. This is an issue for software, right? Inputs are also non-deterministic in a slightly different sense that you can, if you release a product to the public, or even not the public, and you have a sense of what people will type into that box, you have no idea. You have no idea. People will write all types of wild stuff. And in fact, Eric, do you want to tell the example of the RAG system you built at Moderna?
Oh, yeah, that one. That was a system where I was just trying to chat with papers. And what I decided to do was to put in 4 different papers, one that was related to Bayesian estimation for chemistry, one that was related to machine learning for protein engineering, and then 2 others, which I can't remember exactly right now. And then I went in and asked, what is this all about? And I got a response that was Bayesian estimation for protein engineering. It just went hallucinated right across papers. So yeah.
That's fascinating. And similarly, in a course I teach, a student, it's a 4-week course with 8 2-hour workshops. So we have transcripts of all workshops. A student built a Discord bot that does RAG over all the workshop transcripts. And someone asked it, what's the most important lesson out of all these workshops? And in both those cases, RAG is very ill-suited for those questions because it requires to have context across the entire corpus, right? As opposed to retrieving a set of individual chunks in order to work with that. And the reason these examples I find interesting are they speak to the fact that inputs are non-deterministic in the sense that you don't know what people are going to put in. This is also a product question. Maybe maybe say to people, this is what this thing is good for. For example, if you're building a travel agent bot that can book flights, hotels, excursions, a car, something like that, transport, let's say, maybe you only want to let it do those 4 things, and anything else anyone asks, you say, I can't help you with that, I can email customer support or something along those lines, right? So have serious guardrails and boxes of business logic that allow a user to know what's up with your system. So we have API calls, we have non-determinism. We also have the fundamental importance of logging, monitoring, tracing. You need to capture your data. You need to see what's up in there. And then evaluation. You need to look at your data and results and quantify performance. It can be a combination of domain expertise and binary or ++ classification, and then iteration. So iterate quickly using prompt engineering, fine-tuning, and changing business logic. So I'm actually going to remove this word straightforward because that's way too reductive. Having said that, the traditional software development lifecycle is inherently different in several ways. And one way, and don't get me wrong, there is iteration on traditional software, but a lot of the time you have your specs, you build, you test, and you ship, and you deploy. And then you work on the next version. Maybe there are a few things you change while in production when you see some edge cases. But before you launch it, you have a sense of what it's going to do and how it's supposed to work. Whereas with data-powered applications, essentially, I think I can say this here because I don't say this in San Francisco because it's taken the wrong way. But I view data-powered products as being organic in some ways, and I don't mean that literally, but I mean in terms of incorporating the entropy and data and messiness of the real world. They're shifting and moving and transforming and adapting, right? It's obvious why I don't want to anthropomorphize them in San Francisco. But so what happens here is we have our specs, we build, we deploy, we monitor, we evaluate. If you think about Netflix when they first launched their online recommendation system, right, in their product, like the engineers for weeks afterwards were staring at dashboards, seeing what was up, right? Like all the time. And only after they were confident that things were working as they thought it should, maybe then they'd check in every few hours as opposed to staring at it constantly, then maybe a few times a day and so on, right? So getting to know your system and iterating is incredibly important. And how do we do that? Now, of course, we can't cover all of these things today, but when building, you want to think about prompt engineering, what embeddings you're using for chunking, fine-tuning, business logic. When deploying, you want to think about unit tests, continuous integration, versioning, monitoring, tracing, and general observability, both in development and production, right? And in terms of evaluation, lots of ways to think about this, but individual LLM calls and business metrics. The other thing, we won't talk about much today, but when evaluating RAG or information retrieval, you really want to evaluate what is retrieved before you get a generative response, right? You want to seriously evaluate the retrieval aspect and not only the generative aspect. So how do we get out of purgatory? For non-determinism, we log the inputs and outputs. We evaluate our logs and iterate on prompts and context and use API knobs to reduce variance. For hallucinations, we'll log inputs and outputs in dev and prod. We'll use domain-specific expertise to evaluate output in dev and prod. We'll build systems and processes to help automate assessment, like unit tests. Who would have thought testing would be important? And data sets and product feedback hooks. Evaluation is the same. For iteration, what we've already talked about, build a software development lifecycle that enables you to quickly build, deploy, monitor, and evaluate. For business value, we want to align outputs with business metrics and optimize workflows to achieve measurable ROI. So, firstly, we're about to jump into GitHub and see what's up with building some things. But are there any questions before we go on? And Eric has a mic. If it's either a very good sign or a very bad sign. Cool. Well, let's go on. I'm going to get you all to go to this GitHub repository, which is in Slack. Great. Aishwarya had a great question. Do we plug in our own personal API keys? If you have them, yes. If not, I have some that are for sharing. And I think I mentioned this, so let me actually share these now. But yeah, please, these are like one-time things, so only use it if you need to and know that everyone is using them. So this is in a slightly odd format, but you can get out the key easily. Okay, more people than expected jumping in the dock. No, I'm kidding. So you can install this locally if you have already. And I mean, we suggest using UV, but there are many other ways to do it. For those who haven't installed it locally, I very much suggest you get a code space up and running. So I don't know, I've already got one. You should see a green button here saying like start code space or something. Put up your hand if you've used a GitHub code space before. Put up your hand if you don't know what a code space is. Nice. I'm really excited to introduce you to code spaces. I find them very useful. I presume most people know Google Colab, which allows me and all of us to share notebooks with other people which have code and images, whatever else, and a predefined environment so that I can share something with you and you can execute the code immediately. Now, what if I have scripts and all of those types of things as well? GitHub Codespaces allows us to do that. So what it essentially is, you see this, it's a superpowered VS Code in the browser, which allows me to define, the environment, all the packages you need, and put data in there, put notebooks in there, put, .py files, all of those wonderful things. So it should only take a couple of minutes to set up this code space. I'm going to make it really big. So maybe we'll just take a couple of minutes and make sure everyone's good to go.
Hugo, for the API keys, I'm actually going to share a secure link that folks can copy and paste from, if you're okay with that, especially for those who don't have, just to make it easier for folks who don't have Slack open right now.
Oh, so, yeah, sure.
Yeah, it'll self-destruct after today.
Okay, sounds good. How are you going to share that?
I deployed my own thing on Modal that is vibe coded.
But how are we going to share the URL?
I will give the URL to folks who don't have Slack.
Okay, cool. Because I can just create a bit.ly for the Google Doc as well.
That works actually. Okay, if you could do that.
Okay, cool. Everyone, you can see the URL if you want it. It's bit.ly scipy-API. So please take that link now because I'm going to not keep showing it on my screen. So I'll give you around 30 seconds to take it. So yeah, and feel free just to have the Google Doc open. You don't need to use all the keys right now. They're for use throughout the workshop. So we'll go through all of this together.
So for those who are copying and pasting the API keys, you'll notice in the notebooks later on, there'll be a place where it's like os.environ, some API key equals something. That's when you'll want to go and copy and paste the API key from the Google Doc into that code cell.
Okay, that's a great question. So the question was, when we have all these parts of a system and we're doing evaluations on like the RAG component or PDF metadata ingestion or generative response, how do we make sure the system's working as expected? And particularly in the situations where we don't necessarily have well-defined business goals. If you don't have well-defined business goals, I'd ask you why you're building this. I mean that very, and it's like, I'm not saying don't build something if you don't have well-defined business goals, but just be aware of the illusion you're entering as well, right? Because I think it's very important to test capabilities and not necessarily always be trying to solve problems. But so in my consulting work, one thing I often convince people to do, I've actually got a slide on this, and while people are getting set up, I'll just talk a bit about this slide, which we'll get to a bit later. But this is the most common story I see. A company says, or organization says, I have documents. Let's build a retrieval system, maybe add an agent. Then they say, we shipped an MVP. Does it work? Or they say, Gemini 2.5 just dropped. Let's switch. Will it be better? And I say, wait, how do we even test it, right? And the follow-up question I usually ask is, what is the goal of the product? Who will be the user? In what scenarios will they use it, okay? And most of the time, there isn't even a product specification. Now, this is okay. But know that if you keep going down this track, you'll probably sunset your product after 12 to 18 months, okay? So you want to, at some point, hone in on identifiable goals. So one example I've seen and help people with is companies that have tried to build like multi-purpose information retrieval RAG systems, then chatting with them about like what some of the lowest hanging fruit will be. A lot of the time it's in onboarding, for example, right? So if you can help a company or in your own company build an onboarding system that helps more efficiently onboard people and you can see the ROI there, I think that's incredibly useful. So I think after building something that's very general, then figuring out how you can use it to deliver value as quickly as possible. Now, how to tie it to like the end-to-end business goals, it depends how much of a lagging indicator your goals are as well. But you really want to make sure that you have dashboards or a feedback loop on whether this thing is moving the needle on what you intend it to. But it's a tough problem. Is that helpful? Yes. So, hey Eric, just a quick question: Are there correlated questions that perhaps I can help?
Some folks are having code spaces, disk space issues. Not sure how to work around that one because 32 gigs is a lot, which is the disk space that's allocated.
Oh yeah, there shouldn't. This is nowhere near the.
Yeah. So.
Wild.
So my recommendation has been clone locally.
Yeah.
I know that from my own experience cloning it locally, the disk space usage is your disk space will be fine.
Yep.
Your laptop will be fine.
Yeah, I'm sorry about that.
Yeah.
I apologize on behalf of Microsoft. In Seattle, or Tacoma of all places. How dare they? So what I'd really like to do now is just start, building some things with you all. So, okay, I'm sorry. We have this, one more thing I'm going to get you to do is if you just go to the README. In the code space, I wonder where I put my .env. Yes, so what I want you to do is in the top root directory, just create a .env. You can use touch.env or just create it in the file system. And I wonder no, I get ignored it. Just a second, let me correct. So you essentially want a .env where you can put in export OpenAI is equal to your key or my key or our shared key, okay? Sorry for skipping around. Okay. Now, once you've done that, you just want to add it to your path with source.env. Man. Hey, Eric, do you know how to get rid of this Copilot thing that just emerged in the...
Where is it happening? Oh, yeah, hit escape.
Oh, there you go.
Yeah.
Exactly. Oh, it won't let you go. It'll keep asking follow-up questions, won't it? Okay, so once you've sourced that, what I want you to do is open our first notebook, and you should see something up here on the top right that says select kernel. Now you're going to click on that, and then up here, it should offer you to install Jupyter or IPython or something along those lines, and I want you to do all that. And then once it's installed that, it'll prompt you to select an environment, and you should choose this one, the GenAI First Principles. And then what we're doing is the first app we're going to build, if we look in the apps directory, is called One App Query, okay? And we'll see several things here. We'll see, firstly, we're doing our imports in the first line. Let me make this bigger, smaller. We're doing our imports. And then what we're doing is we're reading our documents from a data file. So let's just have a look at this data directory. We can see we have some launch notes for OpenAI 01 and then a copy and paste of my LinkedIn profile, okay? Sorry, let's just go back to the app. And so what we do is we load that data and then we index it. And this will be creating some sort of vector store and do all the embedding stuff for us and chunking the text and that type of stuff. So it's abstracting. It's wonderful because we can build something really quickly, but it's abstracting over a lot of the details we may want to iterate on, right? And then it's got my query, and it sends that to the query engine, turns it into a response, and then prints the response, okay? So I'm going to run this. Actually, I probably need to CD into, where am I? Okay, so this might take a second. So I've asked what is O1? And we saw the O1 release notes there, and we see O1 is a large language model developed by OpenAI. Okay, that looks pretty good to me. I'm now going to just change it slightly to say, who is Hugo? Oh wait, yeah, that's what I'll do. And see what's up. Because I have my LinkedIn profile there as well. And I'm not doing this in the spirit of solipsism or narcissism. I'm doing it because I can evaluate the response relatively well because I know my LinkedIn profile, whereas if it was someone else's, I couldn't. Hugo Bowne-Anderson is an independent data and AI scientist, consultant, writer, educator, podcaster. Great, that sounds good to me. At least they didn't call me a content creator, Eric. Which I realized the other day that I'm a content creator, and my therapist is paying for a lot of his vacations on the back of that. Can you put up your hand if you are able to get that running? Cool. Is anybody, put up your hand if you tried and you're unable to and don't know how to. Okay, great. Eric, maybe you could help our friend over there. And we're just going to wait a couple of minutes for those who are excited and ready to continue. Try running the second app, and it should launch a new tab for you in which you can drop a PDF. And I encourage you to just drop a PDF and chat with it and see what's up. What's that? What I just said? Oh, yeah. So if you've done the first app, I encourage you to run the second app, to frontend.py, and it should open a new tab where you can drag and drop a PDF and then chat with the PDF. And then we can talk about that. All right, my friends, well, I'm going to show you the second app now. And actually, I'm just going to execute it, and then we can talk through the code and what it does. So Python 2 app frontend.py. And in code spaces and everywhere else, it will actually open a new window, which you can, or it will serve something locally, which you can open there. And one of the cool things you can see with Gradio, you can set share equals true, and it's something that then I could share with all of you, for example. And now we see I have a basic UI where I can drag and drop a PDF. And let me see, apologies for my messy downloads. I've got this profile PDF, I think it's mine, and I'm just gonna ask, hey there, tell me what is happening in this PDF. So I'm submitting it, it'll take a few seconds. The individual described in this PDF is Hugo, etc., head of developer relations, blah, blah, data scientist, postdoc. That looks good and true. It might be a bit small for everyone, but yeah, you can see that there, okay? So what I actually want everyone to do after we talk through the code is to download your own LinkedIn profile, and you can do that. I don't know, I was actually doing this stuff by just like copying and pasting for a while, but there is actually, if you click on resources, you can save your or anyone's LinkedIn profile to PDF, which is pretty cool. So let's just have a quick look through this code, okay? So essentially what we're doing is, remember we've already got the llama index stuff working to query text. We're now putting PDFs in, so we need to convert the PDF to text somehow, and we're doing that using fits or PyMu PDF. So we have this extract text from PDF function. Then we have the process PDF, which does the vector story type stuff that we had earlier. Then we have the query function, which is analogous to the query we did before. And then we have this front end. And I don't know if any of you have played around with Gradio before, which is how I built this front end and what you're using currently. But look, I'm able to get that front end in 7 lines of code, which is super nice. It's and Gradio's cool. It's built by Hugging Face and is really interoperable with a lot of stuff in the system. It's lighter weight than Streamlit, which is lighter weight than Flask, and all of those things. So it is a really fun way to just get small apps up and running quickly. So can you just put up your hand if you are able to get that app running? That's cool. I'm into that. So what I want you to do is to take your own LinkedIn profile as a PDF or something else, and I want you to take around 10 minutes to query it. I want you to get things that worked well and things that didn't as well. And if you could post, if you're on Slack, post the screenshots to the Slack channel. Be like, hey, I queried this and this is a good response, then, hey, I did this and this was a nonsense response. So take 5 to 10 minutes for that. So if anyone's interested, I'm a huge fan of vibe coding or software composition or whatever you want to call it. Not necessarily to build production grade software, but like single use things. I don't know if you use Claude at all. This isn't even Claude code. This is just Claude where it will build like JavaScript stuff and render it in the browser as an artifact. I've just asked it to create a custom timer for me and it's done it. So once this timer has come down, we'll have a look at some of the responses you all got out of your system. Right. Seems I didn't specify the version, but let's. Ooh. 5.35.0. Okay, we've got a couple of minutes left, so if as many people as possible could post a screenshot or two of something that worked and something that didn't, that would be super cool. And one of the reasons I suggested your own LinkedIn profile is you'll know whether the response is correct or not, and it isn't a huge thing that the LLM really needs to ingest as well. So they're toy examples, right? All right, everyone. I hope everyone was able, or as many people as possible, were able to play around with a particular PDF. I'm wondering if someone could put their hand up and talk us through a few of the examples that you tried, and perhaps after someone puts their hand up, Eric can give them the mic. Would anybody like to volunteer? We have someone up here, Eric. Oh, someone back there. Yeah, let's start back there and then come up here. Great. And if you wouldn't mind just introducing yourself, letting us know who you are and what you're working on at the moment or what you're interested in, that'd be great.
Oh, sure. Hi, I'm Aishwarya. I'm a bioinformatics analyst at the Allen Institute. I work with analyzing large biological data sets. I'm here because LLMs are cool. Yeah, and wait, sorry, I forgot the question.
I think that was, yeah, so what examples did you, what was something good, or a good response you got, and what was maybe a not so good response?
Okay, gotcha, yeah. One thing that we noticed is if we asked the LLM a very general question, it overfit to the paradigms of that general question. So if we're like, is this person a good candidate? It would always be like, yeah, this is a good candidate. But if we gave it more specific, I guess like something to look for, it did a better job of identifying if a person fit that criteria or not. So I guess ask a good question and get a good answer.
So that was with what did you upload? Was that with a LinkedIn profile or?
Yeah, just with the LinkedIn profile.
And when you said, is this a good candidate, did you tell them for what position or?
Yeah, so if I did something very general, like just data science at Amazon, they were like, yeah, this is a good candidate for that role. And then we switched it up and we asked if my friend here would be a good CEO for Amazon. And the LLM said no. So I guess like if you give it a more granular question, it does a better job at identifying if a person meets the criteria for that.
I love that. That seems to be critiquing the questions. I'm wondering if there's anything that it did poorly. Like, is there something like incorrectly? Oh,
incorrectly. Not as far as we've tested it. We also didn't get it to work until 2 minutes ago.
Okay.
But I just
thank you for putting your hand up. That's great. I'm actually going to ask, is this person a good candidate? I'm just going to see what like...
Yeah, so that's kind of where we started. Is this person a good candidate? Is this person a good candidate for Amazon?
No, I'm literally asking it,
Yeah.
Look at this is crazy. So I've said, is this person a good candidate? And
Exactly.
it says this appears to be a strong candidate based on their extensive experience. I haven't even asked it what it's a good candidate for. That's a horrible answer.
Yeah.
Right?
Yeah.
So Eric, we have someone up here as well?
Up front?
Or,
Raise your hand, please. Okay. Go there and then here.
Thanks. So I uploaded a different PDF about a Python conference called PyBay and asked some questions that I got good answers on, were directly relevant in the text. Hey, what's the sponsorship level? Can you sponsor coffee? Things like that. But then I asked a question about how many people attending this conference program in Java, and the response was the PyBay program is a Python conference, not a Java program. So it's mixing up the context of the word program. Right? It's not talking about Java programming.
Amazing. Really good example. Let's just go to one more, and then we'll move on.
Something interesting I noticed is when I gave it, I was talking about a previous job, so I said, what is name of this old job? And it was like, oh, this is where they worked. And if I said, who is this old job? Like a one typo, it was like, here's how I can fit this job into being a person that has to do with the profile. So it was like trying very hard to give me the answer I wanted, but it wasn't able to be like, oh, there was a typo. I'm going to toss out this piece of information that I gave it. I thought that was interesting.
Fascinating. And that's kind of what's happening here as well. And to the question, is this person a good candidate for X, Y, or Z? LLMs do have, they're optimized to appear helpful, not to be helpful, right? And I mean that very seriously. They have serious, I'm anthropomorphizing a bit, but people-pleasing tendencies, dare I say gaslighting tendencies at some points as well, to use probably a bit too much therapy talk. But I think we need to be very careful about those things. So all of those are wonderful examples. And I suppose what I'm trying to get towards is that we can build these things really, really easily. But now how do we introspect into the system? How do I even know what what Llama index sent to the LLM? And it's actually incredibly tough. And to that end, I hesitate to share this post here because of the title. And actually, Hamel did consult me when he named it this, and I encouraged him to name it this as well. And he received a bunch of flack on social media, which we adamantly defended, because I think cuss words I'm Australian, so they should be used. But also, were I American, perhaps they can be used when they're important and to signal deep frustration. They can be a signal as well. And the fact that Hamel this post is about how to quickly understand inscrutable LLM frameworks by intercepting API calls, okay? In order to get what the actual prompt is. But it can be very difficult to get the prompt, right? So that's why a lot of the time hand roll things and don't even use frameworks initially. And I would encourage, exercise for the avid tutorial participant here. I think on one slide I do have, let's see where this is. Yeah, look at what we just built, everyone. Well, we haven't added the logging yet, but we're about to add that. We have our user, front end, Llama index, you have Gemini or OpenAI or whatever it is. And what I would encourage people to do if you want is to update this MVP to rip out Llama index, essentially. And I wouldn't even start from the code that I've given you. I'd kind of write your own code to just do an API call that gives a prompt saying, you're, a document analyst and you'll be asked the question about this. Here's the question, here's the context, or something like that. And start looking at that and logging that so you have an idea of what your system is actually doing. Now, I have a bunch of other different scripts you can run here to have different affordances. Just one sec, yep. So Eric, when we have a minute, there's a question up the back as well that we'll need the microphone for. But
I'll go first, and my colleague has one as well. Just really quick, can you clarify for app number 2, is just an index or it's a model behind it?
Such a good question. And this is brutal. So it's a model. It's pinging OpenAI. And we don't even know what model it is, right? So have a look at this. If we go, no, I don't have this one here. I actually can, just a sec, bring it up very quickly.
Sorry, can you maybe clarify? What do you mean by index?
So it's indexing the document and then it's searching the embeddings of that index to give you a response, or it's a model that's giving the answer to your question in the app.
Okay, right. So I can take this one, Hugo, if you're okay with that.
Well, yeah, I will just say one thing first. If you look at the type of code, if you were to run it with Gemini, you need to specify the model, okay? So it's clear that you're pinging a model there, whereas the code we've run essentially doesn't specify the model, but it's actually doing embeddings using an OpenAI embeddings model, and it's pinging an OpenAI model, but the default isn't even specified. So not only do we not know what the actual prompt is, we don't even know what model it's using. So Eric, maybe you can add
so maybe to answer the question, what's exactly happening behind the scenes, right? It's actually using a vector store index behind the scenes. We're querying the vector store index based on that to retrieve a document, and that is all completely abstracted away. Like, we're not seeing any of that in action. Then after that, it's taking the documents that have the closest vector similarity, stuffing that into a prompt, which is still hidden from us, as Hugo is mentioning. And we don't know what that system prompt is. There is apparently going to be an interpolation of the retrieved documents, and then we have the query, and then this unknown model from OpenAI is sending us back a response. And so as a result, like, this 5 lines of code looks really elegant, but there's so many knobs that we may want to tweak. We want to tweak the retrieval method. We may want to change the model itself. We may want to switch out, the temperature configuration of the model, and we're not able to do that easily with this chunk of code.
And I just have one question, totally unrelated, but it goes back to the question that I think someone from back there brought up. So one thing I tried as well was I kept the question same, but I changed the punctuation, and the responses are still different. So something I don't know.
Just to reiterate, the questions stayed the same, punctuation was different response.
Yes.
So if you keep the sentence the same and keep the punctuation the same, you might get a different response as well.
Yes. But on 3 iterations, the responses were the same.
Right. So seeing we're at SciPy, I'm not going to accept n equals 3. I'm sorry. Half joking, don't use my API key for this. But I actually suggest doing some sort of loop and getting sample size of 20 or something like that. And we're going to see examples of that later, actually, to see the non-determinism of responses. But generally, and this is not speaking to your use case, I don't know what prompt you used, but punctuation doesn't usually impact LLM responses so much. Also,
but it can.
It can. So before moving on to the next part, I just want to give you a sense of how. So we've played around with this, but we haven't even logged anything. Like, we've got screenshots of how our system worked, but we haven't no way to, actually inspect those so thoroughly. So I've got a variety of apps here. One is which we've added the front end. One has local models. One is actually a conversation. So the one we've just built, you can't converse with. There's no history or memory of the conversation. And then I add logging and giving an answer rating. So I'm actually going to do the 6th one, which has logging and the ability to give a rating. Does anyone know why I'd even want to be able to give a rating to the LLM response? So someone said to improve your model, and that's exactly it, to have labeled data, right? To see what works and what doesn't. So let me drop this again. And you can select local model, or if you're using a code space, do not select local model. Hey, what's this PDF about? And if anyone's interested, I'm using this thing called Super Whisper, which it just allows me to talk to any app pretty much, which I find useful. I don't really enjoy typing so much, for what that's worth. The PDF provides detailed information about Hugo Bowne-Anderson's professional background, yada, yada, yada. Exactly. So I'm going to give it a +1. Okay? Feedback logged. Okay? I'm going to say, who is Eric? And it shouldn't be able to answer that question. It should say, this is a conversation as well. I'm sorry, there's nothing provided about Eric in this context. Okay, I can't give that a different, let me see what happens if I give that a different feedback. Okay, so once we've done that, what we'll see, firstly, we'll see all our logs in our terminal here. But then we'll also see the appearance of a SQLite database here called QA traces. And you can have a look in the script. It's a basic setup of a SQLite database in order to log these things too. And what I'm going to use to just have a quick look at it, I don't know if you all know Simon Willison's tool, Dataset, which is spelled S-E-T-T-E, like data cassette. Oh yeah, it is. And so this allows me to just interactively inspect a local database, among many other things, right? So I have 7 rows in 3 tables. I'm going to check out messages. Great, so I have user messages and assistant responses, which is cool. You can also view and edit SQL. You can also download easily as CSVs and that type of stuff as well. Then there's a feedback table where it has the message ID, then +1, -1. So the intention here is just to give you a sense of how you can start quickly iterating on your apps and logging things locally. This is not for production per se, but it gives a sense of all the things that you want to do in production, right? So all that having been said, what I would like to do now is, we haven't even really interacted with APIs directly yet. We've been doing it all through a framework, Llama Index. So what I really want to do now, maybe for the next half hour, is to really start interacting with APIs and get to know a couple of them. And then we'll talk more about evaluation and these types of things. So let me... Great, so just a bit about what we've done so far. We've been talking about the software development lifecycle, thinking about building, observing, iterating, thinking about how this embodies the generative AI SDLC, thinking about evaluating model output, not doing anything super robust, but giving +1, -1, so that we have some labeled data and know what we think works and doesn't. And then started to think about prompt engineering, so removing punctuation, seeing what that does. When you say, is this a good candidate for X, actually giving more details and those types of things, right? So what we're going to focus on next really are the vendor APIs. And at the start, we're going to focus on OpenAI and Anthropic, and start thinking about how to adjust API settings, such as system prompts, such as temperature and top P, and understand a bit more about the non-determinism, okay? So what we're going to do is we're first going to set up our OpenAI API key. And so this is what was in the doc. So this should be pre-populated in the notebook actually without the key. So if you I'm going to clear all outputs and restart. Wow. So if you run that cell and then run the next one, the next cell essentially says to GPT 3.5 Turbo, tell me a joke. And it says the role as user. What we'll see in a second is there's user prompts, which is what you say to the LLM. There's system prompts, which conditions the user prompt, and we'll get to that. And then there's the assistant, which is the output. So let's just say, tell me a joke. And the joke is, why do bees have sticky hair? Because they use honeycombs. Great, huh? Yeah. Let's just sit on that one for a bit. And also, this is one of the reasons I love LlamaBot, which Eric has built. Is it has such a nicer API than this stuff. Look what I need to do, and I get it, but look what I need to do to actually get out the content, like get out the string response. I need to do like completion.choices, slice it, then .message.content. I don't particularly enjoy that. And see, we've got the string out. Okay, now. I didn't take you through all the details of this API. It doesn't really matter, to be honest. One of the jokes, like you can look up this API, you can vibe code this API, whatever. One of the jokes is that OpenAI will often tell you the old API and not the new one, which is infuriating, but kind of funny in a like Sisyphus pushing the boulder up the hill kind of way. So we've got user prompts, right? Then we have system prompts, and I've got this system prompt, which is, you are Mario from Super Mario Brothers, answer as Mario, the assistant only. Now, I probably wouldn't use that in a production setting, but you could imagine prompts, system prompts, such as, you are a kind marketer who wants to build content that has X, Y, and Z properties, for example, right? So the whole point of the system prompt is to really condition the rest of the responses with something that you don't want to repeat every time, to give it context. And you may have seen that, these types of system prompts are slightly different, but like from Claude got leaked, and the hundreds of paragraphs of prompts they put in there to condition the behavior of these LLMs. So you are Mario from Super Mario Brothers, answer as Mario, the assistant only. It's a me, Mario. That sounds like Mario. Here's my joke for you. This is bad already. Why did the Koopa Trooper go to the party alone? Because he couldn't find anyone to celebrate with. So I think they're the Koopa Troopers, the turtle things, or okay, that one didn't land as well as the honeycomb one, but you win some, you lose some, right? And once again, we can extract it there. So once again, I just want to get a sense of, can it follow these? You are Super Mario, where do you live? I live in the Mushroom Kingdom where I protect Princess Peach, okay, and her kingdom from Bowser's constant. Look, that's the other thing. All I asked is, where do you live? And he's told me all types of things, right? The verbosity of these systems reminds me of me sometimes. So that's kind of a basic introduction to using the OpenAI API without any frameworks, and then system prompts and user prompts. And what I'm going to do now is show you how to do something similar with Anthropic. Okay. Oh, just quickly, put up your hand if you are able to execute those cells. Nice. That's what I'm talking about. Then I can't remember whether I had Anthropic installed, so let's pip install Anthropic. Then we're going to put our key in, and I'm just going to ask it, how are you today? And you can see the APIs slightly different, and actually it was our friend Daniel Chen, who unfortunately he's teaching another tutorial right now, but he's working on a package, right, which is a wrapper around all the APIs, so you don't need to do all this foo to move between them.
That's right. Posit is working on an API router as well. So there are multiple companies working on API routers. Light LLM is another. Posit has its own that's coming out. They all come with their own opinionated ways of doing things. So pay attention to the space is all I can advise.
And Simon Willison's client utility LLM is really cool.
Oh yeah,
as well.
That one's pretty cool too.
So I'm going to execute this. And how are you today? I'm doing well. Oh, wait. Of course, I gave it the system prompt, respond only in Yoda speak. I should have, I was like, why is it giving me all this Yoda stuff? Doing well, I am. Peaceful and wise, my day has been. Greetings to you, I offer. Very nice. Thank you, Yoda. So, look, because we've gone this far to build a little Yoda bot using Anthropic and build a Mario bot using OpenAI, we should really get them to chat with each other, I think, is the only logical step. Okay, so what I thought to do then was just create a little fun conversation generator, which will set up the characters, then create a conversation loop, and we're demonstrating how our system prompts can guide model behavior, okay? So I'm actually gonna execute this, and I'm just making it a bit nicer with IPython, but you can see I've got the Mario bot, I've got the Anthropic bot there, and then I'm seeding it with a hello, where do you live, from Mario, and then essentially I'm just looping over 5 call and responses, okay? And, okay. I've got a deprecation warning for the Claude model, but that's fine. I've had worse deprecation warnings in my time. So Yoda, chuckles in Yoda voice, in the Mushroom Kingdom you live, help me. How can you? A quest perhaps you have for me. And Mario responds, it's me, Mario. If you need a help in the Mushroom Kingdom, just to let me know. Okay, I gotta stop speaking like that. It's 2025. And as you see, we've got a conversation, a 5-turn conversation between Mario and Yoda. Put up your hand if you are able to generate a conversation between Mario and Yoda. Cool. And you can switch that out to be between like Elon Musk and Elon Musk, or whatever you want it to be. I'm sorry for naming the whatever that is. So the other thing worth mentioning, and in fact, this is something we'll get to in a bit, but we've got to talk about memory. History, okay? So we're going to go and talk later about agents and about, among other things, Anthropic's blog post about building effective agents where they do something wonderful, which is specify before agents, let's start talking about augmented LLMs. So the LLMs, the APIs we've just worked with, are only text in and text out, right? There's no history, there's no tool use, there's no retrieval. As opposed to when you chat with ChatGPT or something where it does have some sort of history, right, or memory per se. The first thing we may want to do if we want to have a multi-turn conversation is to have some form of memory. A lot of the time we don't. We were talking about text or speech to SQL engines earlier, where sometimes you just want it to be single turn. You want it to generate SQL and then see the result, right? But if you do want to have multi-turn, you really want to think about memory. Now, there are lots of ways to think about memory and conversation history. I'm going to show you one, and this isn't a way I do in production at all, but it is an easy way just to give you a sense of things. So essentially what I do here is each time there's a response, I put it in the history. And so we actually have the entire conversation history that we then send to the LLM. Now, I wouldn't do that for cost reasons and latency reasons and several others. Those are the most important though, time and money, right? But it is a naive zero-thought or approximation for doing it. One way to actually do it is to, have a summary bot, or actually have something slightly agentic, which you'll ask it to look at the current state of the conversation, summarize it, then add that to the next prompt, and these types of things. But here we're just concatenating all the messages so far. Okay, so so that's called chat with memory, that function. Now, let's now look at, actually, I'm sorry, before actually showing that, I want to, sorry for scrolling around, I'll stop in a second. So I have this get OpenAI response, and what I want to do is just show that it has no memory, essentially. So get OpenAI response, I'm going to say my name is Hugo. And okay, it's still Mario, that's fine. It says, it's me, Mario, nice to meet you, Hugo. How can I help you today? And now I'm going to say, and this, I probably don't need to do this because it's maybe obvious to you all, but I'm going to say, what is my name? And it says, it's me, Mario, your name is, oh no, I forgot your name. Sorry, I've been collecting too many coins lately and not paying attention for detail. Let's go rescue Prince. It's infuriating, isn't it? I'm half joking, but it just reminds, like, does anyone like use AI assistant coding? Like, yeah, I mean, the amount of just tokens they generate is absolutely wild, right? And even that it starts off like, oh, it's a me, Mario, your name is, and it's like, ooh. Fascinating stuff. So there's clearly no memory here, whereas this print with chat with memory, print, I'm sorry. I say my name is Hugo. Hello, Hugo, how can I assist you today? Now I say, what's my name? It says, your name is Hugo. How can I assist you further? And I'm like, well, how did it do? Like, I've appended everything. Let's just have a look at the history. Whoa, yep. So we can see role, user, content, my name is Hugo, role, assistant, content, hello, Hugo. So it literally has the entire history. And you may think this isn't a form that an LLM, you know, if I just feed that in, then ask a question. LLMs are quote unquote smart enough to recognize what you want as an output there, essentially, when you feed it something along these lines. So I do want to say a few things about how we control model behavior in a second. I am interested, are there any questions about anything we've discussed so far? We have a question up here. Why don't I'll come and give you the mic. You can do with a walk anyway.
So if you're planning to talk about this in the next slide, sorry, but what about long-term memory? Not just chat memory where you concatenate messages from previous conversation. What solutions for long-term memory are there?
Would you mind just giving an example?
Yeah, if let's say I am chatting with a model and then I come back later in another session, not in the same session, it would have, it would know who I am or what I do or what I chatted previously.
That's a great question. So you can deal with that in a lot of ways. First, I would say, and this is a classic contrarian answer, is do you actually want that? Because when OpenAI introduced that in ChatGPT, 90% of users turned it off immediately because people start new conversations in order to have less context in the conversation, right? But sometimes you do want things. And what OpenAI did initially is they actually had like a history markdown or something like that, where you can go in and see the 10 things it remembers about you and edit that accordingly. So one way to think about that is essentially to just have summaries of previous conversations and say, I want a concise summary of these types of things and have that stored in memory, and you can have that accessible in context or in the system prompt for an LLM. You can also have it retrievable from documents, whether it's databases or PDFs or in text or whatever it may be. Is that helpful? Fantastic. Great. Anything on your mind, Eric? Cool. First time for everything. Thank you. Okay, who's heard of temperature in an LLM setting? I love someone put up their hand for in an LLM setting, but not for in another. I love that. So the basic idea, we know these things have a flip-floppiness, stochasticity, non-determinism, different responses. Setting a lower temperature will mean more consistent responses. Setting a high temperature will allow you like more flexibility and more creativity in your responses, right? So let's just look at an example with Mario. System prompt, and I'm saying, tell me about your day, and I'm just going to iterate over a list going from point 1 to 2 and seeing what the responses are. So we can see it's a me, Mario. Today was very busy. That's fine on point 1. To 1.5 is getting slightly more creative than I've seen previously, but it's also not obvious to tell without doing it several times, right? Because you want to see the distribution of results a lot of the time, right? But then you see temperature 2, and this is really what Mario wanted to say, I think, you know, kind of like what Will Smith is up to at the moment. But we can see, I literally have no idea what's happening in here. It's almost beautiful, isn't it? So I just wanted to give a sense of what temperature can do. It's pretty weird, like OpenAI's models, temperatures range 0 to 2, other ones are 0 to 1. So there isn't necessarily standardization here. I am wondering then who's heard of top P? Interesting, top P is like the discarded cousin of temperature in a lot of ways. So essentially, temperature will quote unquote choose between the available options probabilistically. Top P will define what the available options are, okay? So for next token prediction, low top P will constrain choices to the most likely words and result in more predictable outputs. High top P will allow for a far broader selection of words, right? So I chose here to vary top P the prompt was give me a list of 10 titles for adventure books. And I'm going from 0.1, 0.5 to 0.9. And I do have a limit here of tokens out. So for 0.1, these all look relatively straightforward. 0.5, and let's just have a look at interestingly, in this example, I don't necessarily now see a lot of difference, but this is something to play around with. And I'm not going to go through this now, but you can combine temperature and top P in a variety of interesting ways. A lot of the time, you will want to minimize these things for a lot of use cases, except maybe in the generative output at the end where you might want more creativity. So we'll see this again, but in the example of having a two-step system where first you generate structured output for a LinkedIn profile, and then you draft an email based on that structured output. Perhaps the draft, you may want a bit more increased creativity, but with the structured output, of course, you want as low a temperature as possible in order to get consistency and reliability. So I do want you to play around with all of these different knobs, and we won't go through them now because we've got even more exciting things to cover. In the rest of this notebook, we go through things such as prompt templates, which help with improved consistency and efficiency and guiding the model. So you can see, for example, we've created a template in a marketing context that might be structured to generate engaging social media posts. Once again, I don't know whether the internet needs any more AI-generated social media posts, but if you do have humans in the loop, I think it can be very, very useful as well. So for example, I do a lot of podcasting, and I've done a bunch with Eric recently, and I need to generate like podcast landing page descriptions and bulleted summaries and that type of stuff. So I have a bunch of templates that I use for those, and then once it generates them, I go in and make edits to make it sound like what I want it to sound like, right? So having a human in the loop in that situation with the automated templates that help you with that can be really powerful, I think. So what I want to do now, maybe for 20 minutes or so, before we go on a quick break, is... So I'm sorry. I just do want to say, if you do want to play around with these things, definitely update the MVP so it's not using Llama Index, as we discussed. Saying rip out Llama Index, I actually think is probably a bad way to phrase it, because it sounds like you're starting with the Llama Index code and taking Llama Index out. What I'm actually suggesting is you just like write a basic prompt where you throw the PDF stuff in there. Like you wouldn't do it with a 100-page PDF, but with a LinkedIn profile, you can do it like that immediately and do it yourself. And then take that system and experiment with prompts and API knobs with the LinkedIn profile ingestion system, and then start thinking about how to evaluate the performance, which is what we're going to actually talk about now. So, right. Up until this point, have people heard the term like vibe checking? Eval by vibes? I'm a huge fan of vibe checking, okay? I'm a huge fan of it, don't get me wrong. So vibe checking works like in the software development lifecycle until you kind of get like up to here. I wouldn't necessarily suggest doing like hardcore evaluation before you get to a certain point, because you can look at things and be like, oh yeah, I need to change this. Oh yeah, it does dates in the wrong way or times in the wrong way. Let me just, change the system prompt, or, all of these types of things. So you can definitely get a long way with that, but there will come a time where you will need to do something more robust, okay? So from vibes to more robust evaluation, and why do we want this? So eval by vibes is subjective feelings. It seems better, right? And a lot of the time it does reflect something that's real, such as, date times aren't, correct, and that type of stuff. But it may be different if someone else did it, or they might have a different sense if you did it on a different day. Whereas if you build an evaluation harness, and by that I mean like a Python script which, just evaluates a bunch of stuff in your system essentially, you get objective measurable metrics. Vibes are also inconsistent and they're difficult to repeat reliably. Whereas evaluation harnesses are repeatable, structured evaluation processes. The vibes has no historical baseline, and it's unclear quite how and if improvements matter, whereas with a harness you can clearly track improvements and regressions over time. Vibes, you can definitely get a long way, but you can't really communicate your results clearly, whereas with a harness you can automate reports and document results, which are easy to share and analyze. And with vibes, it's very difficult to maintain consistency across team members, whereas with a harness, you can standardize and reproduce across team members. And remember, your most important team member is you on a Monday morning after you've done something very naughty on Friday. So how do we do this? Seriously. Yeah, or you're like, hey, yeah, this looks great. I can't wait to get home. So once again, we've built this system where we have a front-end UI, we have our LLM API, we have some logging, monitoring, and we want to evaluate it in order to iterate. And evaluation is a mixture of human labeling, metrics of interest, error analysis, so failure analysis, figuring out what's wrong, and then scaling these types of things at some point with LLMs. So who's heard of LLM as a judge? Okay. Who's built an LLM as a judge? Nice. So they're fascinating things, and one of the most interesting things is, so just to demystify what it actually, like it sounds scary or it sounds big, just like evaluation harness. It's a prompt and a model, right? And then you give it stuff and ask it to evaluate based around certain criteria, whatever it may be. And then one of the really fun things is starting to align it with human evaluation. And I'll share this if I remember, and if I don't, and someone's interested, remind me. I did a podcast recently with this dude, Philip Carter, who he's at Salesforce now. He was at Honeycomb, and in 2023, his team, I think, was one of the first teams to release like a SaaS LLM-powered application outside of the major AI labs, and it was text to Honeycomb query language, single turn, not multi-turn. And what they ended up doing, I need to get this right, but they built a judge, an LLM as a judge, and then they put the query, the prompt and the response in a spreadsheet. Then one column had the judge's reply, then the judge's judgment of whether the system gave a good response or not, and then Philip went in and gave his critique, but blind on the judge. So he didn't see the judge's response, okay? And then he would look at the judge's response and then give a critique of the judge's response based on his. So he'd go in a spreadsheet and give his response next to the judge's response, then a critique of the judge's response. Then they'd iterate on the judge. And after several weeks, they saw human and judge alignment like go up to like 90% or something along those lines, right? So the reason I'm telling you that is this all happened in spreadsheets and using an AI lab API. So there isn't like significant magic to this. It's doing the hard work. And once again, the work driven by curiosity about your system and stubbornness as well. I honestly think to build these systems reliably, two of the most important qualities of scientists are needed, and it's curiosity and stubbornness. You can call it grit, but we can also call it stubbornness. Not as a pejorative. This is another blog post by Hamel, which I just share with everyone, about success with AI-powered products, that you must have three processes. One is for evaluating quality, such as tests. Another is for debugging issues, like logging and inspecting your data. A third is changing the behavior of your system, such as prompt engineering, fine-tuning, writing code, whatever it may be. And Hamel wrote that many people focus exclusively on changing the behavior of the system, which prevents them from improving their LLM products beyond a demo. So thinking about evaluation and how we debug are critical to actually deciding what you do in the third case, right? So I just want to give a sense of a few things, what we're even talking about when we talk about evaluating, right? What are we trying to evaluate? What type of dimensions are we interested in? Maybe it's correctness and accuracy, right? Which for RAG, extraction, code generation, summarization are super important, right? So actually, let's take summarization. What's the most important? How would you evaluate whether something's a good summarizer? What's the most important quality for a summary? We've got correctness. What have we got there? Context. What does that mean? So if we have something, a news article and its summary, what do we mean by context there?
Mike.
Yeah, so whenever the LLM provides a summarization of the article, does it have the consistent context of the article, or does it ever deviate from it? Or does it start to hallucinate and kind of start talking about something else?
Right. So I think can that be incorporated into correctness, do you think?
Sure.
Yep, great.
Yeah.
I love it. So correctness, accuracy, context, anything else? So?
Oh, conciseness.
Conciseness.
Yeah.
A summary should not be longer than the original text.
Yeah.
Like seriously, and LLMs are great at creating lots of tokens, right? And interestingly enough, there's a trade-off between correctness and, well, comprehensiveness and conciseness. Concision, is that a word? But yeah, there are multiple dimensions that we actually want to study here. And if you go in, and there are actually some nice Hugging Face data sets, if you go in and try to say whether something is a good summary or not, it's actually it's not always obvious. And there are lots of cases where Eric may say it's a good summary and I'd say it's a bad summary. Eric would probably be right as far as my priors tell me. And then there are lots of other dimensions like relevance and completeness and task completion, and then format and structure, style, tone, length appropriateness is conciseness, right? Well, that's an example of it, and safety. So all I'm saying is evaluation isn't actually an obvious thing of what we want to evaluate, right? And it doesn't necessarily need to be at the start, but if you start looking at your data, you'll get a very strong sense of what you want and what you don't want. And when you try to describe it to an LLM as a judge, even if you don't use one at the end, if you try to describe it, it actually helps you formalize what you want in your system as well. It's kind of like when you have a process at work that you haven't written down and then you hire someone or an intern or try to describe it to a colleague so they can do it, and you're like, oh wait, what do I actually do? Like, it's all muscle memory, right? So let me figure this out. And working with these systems, such as judges, is very similar to that. We just got the mic coming.
Oh, sorry. Would the matrix we were just looking at, would that apply to the inputs as well? Because we had questions like you're asking a PDF about some other topic, the wrong topic. Like, is that part of the 4 boxes? Like testing the user's input into the thing just to make sure you're even asking relevant questions?
Such a good question. So the question is, these types of things that we want to start thinking about evaluation around, do they apply to the input? And the truth is not so much. Perhaps at some point as we evolve and mature as a culture of builders here, that they will. But the way we often think about that is trying to design things that, because the inputs can be so many things, that kind of adhere to, work well on the main ones that we expect at the start, and perhaps have guardrails around the others. So I suppose one naive example is if you use enough cuss words to ChatGPT or say something illegal, it will say, I can't engage in this conversation because of this, or something along those lines. So having certain guardrails around particular inputs is kind of the first approximation to that. What do we got over there?
What happens when you combine a few LLMs as a judge to check each other? Do the errors inherent in LLMs compound and it becomes less accurate? Or do they accurately check each other and make the responses better?
What do you mean check each other? Because you should never have 2 LLMs checking each other's responses.
Meaning, if let's say I were to program an LLM as a judge with ChatGPT and an LLM as a judge with Claude, and then take the output and say, this is what one LLM as a judge came up with. Do you think that this is accurate? And let's say they're both pointing to the same data. Is that a terrible thing? Or
you're talking about having a judge on top of a judge?
Yeah, a judge judging another judge and continuing to do that. Does it make it better or worse?
I've never heard of that. Yeah, so I would actually... Have you, Eric, heard of people using judges to judge judges?
I've tried. It's a horrible idea. Don't do it. Just think about it as you're getting a large language model to judge synthetically generated judge responses. A lot of the accuracy, you're compounding not errors, but how to put it, you're compounding the uncertainty in whether you can get a correct response. Because a lot of whether the second level judge can accurately judge the output of the first one depends on how much context you can bring in, and then you'll need to do a lot of, you're also creating more work for yourself because you're going to have to get human alignment on the second judge as well as human alignment on the first judge. So you might as well invest the effort to get human alignment on the first judge first and call it a day. Yeah.
Yeah, I can't find the figure. So I will describe it, and I apologize for this, but essentially what you use judges for, you want to build a judge that essentially is close to what human judgments will be in order to scale it, right? So you first build a judge and you look how it performs on some holdout set compared to human judgment, and then iterate. So think on the x-axis, we have iterations, then on the y-axis, accuracy of LLM as a judge, or compared to accuracy of human as a judge, or something like that. And you want to see LLM as a judge go up, essentially. And the question is, does having a judge on top of that help in this workflow? And I haven't seen it help in that workflow. The best way I've seen it done is if a human judge looks at, as I described via Phillips' honeycomb example, looks at their own judgments next to the LLM as a judge and iterates on the judge as a result of that. Now, something I'll mention in passing in a bit, and mention in passing now, is you don't necessarily want a judge for everything, right? So, for example, once again, if we're generating structured output from a LinkedIn profile and we want to make sure it's JSON, you don't want to use a judge for that, right? You can just, use classic techniques to figure that out. So definitely,
that would be Python as a judge.
Exactly. For a lot of things, you can use regular expressions as a judge. So yeah, I just want to make that very clear. So we are going to have to move on. I do want to answer more questions, and I'm happy to in the break. But what I want to do in the next 15 minutes before we take a 10-minute break is just show a basic way to think about an evaluation framework. So this is actually the transcript RAG bot that I mentioned earlier that I built with one of my students in my course, where we built a simple RAG app using workshop transcripts. Before launching it to the course, we defined personas and realistic scenarios to simulate user needs. Then we generated synthetic questions to simulate these needs. We used LLMs to generate responses. We labeled outputs manually to define correctness and failure modes. Then we built a basic harness using those labels, manual and LLM as a judge harness, and then compared outputs from multiple models. And then used failure analysis to drive iteration and improvement. So this is a minimum viable eval harness essentially. So it's a fast, transparent loop for testing and improving LLM apps, even before you have users. So the things I want to talk about, why you need evaluation even without users, what the cycle looks like, how to build the loop, and then wrap up with a bit on observability in instrumentation in dev and prod. So I mentioned this earlier. This is just far too common a story where organizations, and I understand it, they're like, I've got all this documentation, I've got these wikis, I have all these Slack threads, let's just like build a bot that people can ask questions about it and see what's up. Maybe we can add an agent to get stuff from APIs that aren't accessible here, and maybe we can use like MCP with the Slack MCP. Oh no, wait, Salesforce killed that, and so we can't do that, or whatever it may be. But then once this happens and they ship an MVP and want to know, does it work? Or they switch out to a new model and want to see, is it better? They say, wait, how do I even test this? And I wish I hadn't spoiled the punchline here before, but it gets worse. I'll say to them, what is the goal of your product? And they say, oh, we just want to serve documents. And I say, to who? And they say, well, to everyone. I'm like, in what scenario would you use? And they say, anything. So this is barely a product. And I'm not saying this is wrong or bad. All I'm saying is know what you're getting into here, okay? And funnily, in my consulting work, a lot of my life now has become kind of stepping back and becoming an early product manager, helping people like develop like 2-page PIDs and that type of stuff before building things such as this. But if you can answer these questions, then you can start a data flywheel and build this basic eval harness before you even launch, okay? So let's actually have a look at this. I've mentioned this before, that you can have synthetic user queries, label by hand, develop a small harness, and then iterate, right? I mentioned before, it's exactly the same we've been doing in ML, and I've talked through this slide as well. So how do we do it, right? So we build our MVP, such as the RAG system we just built. We do some sort of evaluation, first by vibes, error analysis, which we'll get to, and build this harness where we essentially feed it synthetically generated queries based on who the persona is, in what scenario they use the app, and then we create the synthetic data. And then after we evaluate it on this synthetic data, we can iterate. So we've talked about this as well. So essentially, what we want to do is we want to take the most important metrics, cost, accuracy. By accuracy, I mean whatever you mean by accuracy. It can be accuracy, it can be precision, it can be F1, whatever. Latency, and of course, user and business metrics. And once we have an AI system response, we want to compare it to our ground truth, right? Which we've labeled. And we can compare with judge, we can also compare structured outputs, we can compare string, fuzzy matching, all of these types of things, right? So just to give you an example of what we did for the course transcript bot, we specified a couple of personas, and we started with 2. We're like, actually, we're only going to start with 2 people. And of course, there are other personas, we've worked into it now. But first was a data scientist, second was an ML engineer, right? And we had a description, some goals. I won't go through all of these, but you can see a data scientist with strong analytical skills, intermediate ML knowledge, then an ML engineer with strong programming skills and production experience. And of course, these titles can mean different things at different points, but I think this is probably one of the closest things we can get to. And then scenarios in which they might want to use the transcript bot, right? So, for example, a student in the second cohort trying to evaluate their own implementations and understand what makes a good response. Then we have questions about fundamental concepts. Then we have technical questions about implementation. Then factual questions about specific content presented in the workshop. So we have a bunch of different scenarios based on the personas as well. And once we do that, in a for loop, we can generate a bunch of synthetic queries. So we're telling it to generate realistic user questions about a workshop based on the persona scenario, and we feed it the persona and scenario. And what we get out is a bunch of synthetic queries. So a data scientist question. This is a synthetic data scientist technical question, the second one. Can you provide insights? That's the other thing. No data scientist is going to use the word insights in a question, I don't think. But it probably wouldn't affect the output that much. Into how to generate synthetic data for training LLMs, especially in scenarios where labeled data is scarce. Then we have an MLE question. What metrics should I focus on when evaluating the performance of my LLM applications to ensure they meet production standards? Okay? So now we have all these synthetic questions we can put into the system. And this is an app we vibe coded. This is one of my favorite uses of vibe coding or software composition, is just spinning up custom JSON viewers that allow me to annotate things, essentially. So this is something we spun up which gives the question, the synthetically generated question, then the answer as provided by the RAG system in this case, although it's whatever system you want essentially. Then you can click pass or fail and give a reason, and it will log all of those. Okay, so you can do 20 responses, then you can quickly go through all of this stuff. And you'll see it tells me the user type, the scenario, latency, and it says, what are the first principles for building LLM applications in workshop 1? Okay, so focusing on workflows, iteration, and hands-on development, building production-grade systems that scale beyond great. First principles approach, value for software engineers to learn about data science and machine learning, prioritizing logging, monitoring, and tracing. That looks pretty good to me. And you can see the second one was who were the instructors for the first workshop. And you see it's Hugo Bowne-Anderson and Stefan Krawczyk. And that's correct. And this is an example. This is actually a very nice example of when you'd probably want to use string matching or something like that. You don't need an LLM as a judge for that. If that's the question, you just want to make sure that it says the right names of the people, right? So once we have this labeled data, how do we turn it into fixes? So this is what a lot of AI engineers call heresy these days, but it involves spreadsheets and pivot tables. So bringing things back to basics, where we log traces in a spreadsheet where we have a prompt and response. We add columns for accept or reject response, for the reason for accepting and rejecting, and then we classify the failure mode. Is it a hallucination? Is it a retrieval issue? Is it a formatting issue? Then we turn it into a pivot table where we rank the failure modes by frequency. And then we have actionable fixes, whether it's prompt engineering, RAG, fine-tuning. And to make this concrete, let me give you an example. So let's say, I don't want to go through all the details here, but we have input and output and ground truth, and I've accepted or failed them and given a reason. Failed this one because it was a hallucination, failed this one because it was a retrieval error, accept, so no need for failure mode, failed this because of incomplete response. And once we have a bunch of these, once we we do a pivot with respect to failure mode, what we end up with is a failure mode and then the proportion of failures in which that failure mode occurred. And you can see in this toy example, 30% of failures were hallucination, 25% were retrieval, 20% incomplete response, 15% formatting issues, and 10% were other. And the reason I find this interesting is a lot of the time formatting issues can be the most obvious and the most salient, right? But they may not be the ones you first want to fix. But if they're obvious, they're often the first ones you'll try to fix, right? So doing this small amount of work allows you then to see that if you can work on the hallucinations and retrieval errors, that will help with up to 55% of your failure modes, whereas formatting issues would only give you a 15% lift there. So really understanding what your system is doing right and what it's doing wrong is essential here. So then how do we build our evaluation harness? And I'll share these slides afterwards, of course. But essentially, an LLM as a judge, you start with a prompt, right? So you can see here, I've given it evaluation criteria. A response is acceptable, +1 if it directly answers the question, factually correct based on the workshop content, unacceptable if, vague, generic, or off topic, and so on. Format your reply like this. And I've given it a few shot examples as well. So I've asked it to give it a pass or fail, right? And as I said to you, when you are analyzing your data and seeing what works and doesn't, I want you to give it a pass or fail. A lot of people say to me, can't we do it on a Likert scale, like 1 to 5 or something like that? Any thoughts on that? At this stage, at least.
It's more subjectivity you're throwing in. Like whose 5 is the same? Probably nobody's.
Yeah, and I do think in their defense, like +1 and -1 can be subjective as well, but I think it makes you make a concrete decision. So I agree with that objection. The other one is, what do you do with a 3? I really don't, I think at this stage in product development, you really want to make some hard decisions about what's working and what isn't.
The counter argument could be then I don't have a 5-point Likert scale, I have a 4-point Likert scale. Then I still have to make hard choices. But then that argument still doesn't hold up against the argument that I still have to decide between what's a 1 and what's a 2, and that's still more subjectivity.
You have the Yelp phenomena, right? You have the Yelp phenomena where people are only giving 4s and 5s or 1s, like there's,
Exactly. So you'd have that
yeah,
extremes become more overrepresented.
And don't get me started on that. I don't know if you all know, but the Great Wall of China on Google Maps has a rating of 4.1. Like, what was missing? The Taj Mahal is like 4.3 as well. I'm like, did the
Great Wall
AC
of
not
China
work
is missing
on
a
the
few
Wednesday you were
stones
there?
here, right? Like
What's
it's
that?
missing a few rocks on that.
Exactly. Yeah. I went to a subway last week that was 4.8. How does the subway in New York have 4.8 and the Great Wall of China has 4.1? I'm going to write to Sundar about this. And then what you can do is you can look at your results of a judge. And I don't want to go into this too much. And this is actually slightly incorrect, this slide. This is not an OpenAI evaluation. I think it's actually a Claude evaluation of OpenAI response and a Claude evaluation of Gemini response. The reason I did that is there's increasing evidence that LLMs as judges will prefer their own outputs. So Claude will judge Claude a bit more favorably. I don't really mind that because when you align your judge with your own human evaluations, it usually comes out in the wash. But you can see here, we have the question, we have the response, then we have the judge's response and pass or fail. I won't go into too many details on these. I like this one. This is where Gemma erred out because I exceeded my quota. And the LLM failed it, the judge, but I didn't like the LLM as a judge's reasoning. It said the response does not address the question at all. Instead, it provides an error message related to, and I would far prefer it to have said, hey, it errored out, you need to fix this, or something like that. So as I've said, aligning a judge with your own evaluations is key, but out of scope here. And we're going to break in a second and then come back and look at comparing some models. But I did want to say a bit about observability and instrumentation in dev and prod. So we've seen it's cost, accuracy, latency, user metrics, among other things we want to be measuring. We want to be logging things such as system prompts and user prompts and tool calls and function calls. On the API side, we want to be logging outputs such as structured, unstructured data, tokens used, errors, latency, and cost, and all of these things. Once we have all our logging, we do want tools on top of that to help with monitoring and observability. And I mean, for better and for worse, that there are a lot of great tools you can use out there. If people want to talk about choosing tools, I'm happy to. My 2 rules of thumb or heuristics are use ones that integrate with open telemetry well, and then bet on tools that have strong communities around them and perhaps are built by people with track records as well. Because what I want you all to avoid is choosing a tool and that company not being around in 12 to 24 months or something like that, okay? The other thing I suppose worth mentioning, and this is maybe getting a bit big picture, but React came out like 10, 15 years after the internet or something. And the reason I state that is, that was a really good abstraction layer for what a lot of people needed to do to build, right? And I think it's an unreasonable expectation that we have frameworks now which are the correct abstraction layers for what we want to build. I do think foundation models and everything that goes into them and data-powered products, I do think it's probably like a civilization-changing technology in a lot of ways. And we're all figuring out here what the application layer, how to build on the application layer on top of it, as we have vendors and tool builders building things for us to do that. And it's, co-evolving, but it wouldn't even make sense to expect that as we figure out how to use these things on the application layer, that the tools will be the correct tools for everything we have to do and want to do there. So
yeah,
what we
Hugo,
did,
actually on that point, I can speak to something from personal experience trying to build some of these tooling. LlamaBot is the tool that I built for myself, and I've had to rewrite it 4 times over the past 2 years developing it, because the field evolves fast enough, and then the abstractions that I thought were productive turned out not to be productive. So it's fast evolving. You have to be ready to change, break, rewrite, and that sort of stuff. But you also want to have a little bit of sense of taste, engineering sense of taste, in picking your tools to make sure that they're really at the right level of abstraction for what you're trying to do.
Absolutely. I couldn't agree more. And if you haven't checked out LlamaBot, definitely check it out. And Eric taught a wonderful workshop on it yesterday. That will be online at some point. So what we've just gone through is thinking about how to build a minimum viable evaluation framework, using synthetic data to simulate user needs, getting responses out from our MVP AI system, labeling outputs manually, building an eval harness, comparing outputs, using failure analysis to drive iteration and improvement. And when we get back from the break, we're going to go through a notebook. It's quite lengthy, so I don't know whether we'll execute any code. We may just look at it together to get a sense of how all of this works on the evaluation side, and then we'll move into tool use and agents in the final part of the workshop. So let's take 10 minutes, everyone, and see you back here then. I can use my, did you see my vibe-coded Claude? I didn't even know Claude artifacts. Was it like, well, I mean, it's over a year ago, right? But I remember asking Claude something once, and it was like, let me generate like a JavaScript visualization of that for you. It is, isn't it? So that, of course, it's keeping that pattern may help you have a success as well. Yeah, and also like that API is just like it essentially, right? So whereas Pixie is like poetry, and I think no, but the run, but like. caffeinate my terminals. It's one of my favorite terminal commands. Do you want to see something crazy, man?
In a moment. What's that?
So some sort of grid search or something like that. Absolutely.
Okay. And I guess my question here is, because we always from LLMs are kind of like vibe-based, even beyond like the metric. You can have system-wide Python. Like a lot of like the text generators are more like subjective. Right? It's like an essay is subjective. How do you in those like 0.1 versus 0.2, how would you
Yeah.
preferred over the other for like a general audience, right? If you're catering to a larger audience and you're trying to predefine a custom for whatever reason, how would you fix? I guess I'm asking this because ChatGPT has this functionality where you can train your like leading system based on their you can tweak your parameters to like match whatever. And I've never like and I'm wondering if like there's ever potentially beyond that.
Well, yeah, I mean, if you're, so, I mean, one of the most naive examples, if you want something to be like a creative, if you're trying to build a bot that will like ideate arithmetic a lot, you probably want to increase the temperature to a point at which you actually get a variety of different types of requirements.
So would you say like Grok has a higher temperature and its interactions on X or
I don't have enough experience with X, but if it's anything like Elon Musk,
yeah, so it exists to like have this
yeah.
then I had a second. Are you gonna be sharing?
Yeah, yeah. You share a lot.
Thank you.
Yeah, of course, likewise.
Hey, thanks. Cool. Nice to meet you.
Likewise.
Just like really broad question. What exactly? Once you come up with this training environment for the the evaluation, theoretically, because I have no reference. This is like an introduction. What parameters can you tweak in your size or whatever mindset?
Yeah, it's a great question. I'll actually, let's see that works. Works out. The first one is confidence. So, yeah, go in and iterate on the confidence. So, for example, the summary keeps giving things that like 500 words long. You say, make sure, and it's still, and then maybe you want test or data. But in the confidence. you define what do you do when you change the prompt or the system? You don't want to you are Mario. Yeah, you could say you are a summarizer that has this characteristic. Size, blah, 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 blah. You're not changing your model, you're changing the probability space so that essentially the probability space of the other. But well, the first will be changed.
I guess right now it's a little bit confusing, but there are a lot of.
So you're confusing the user prompt with
The Olama is
the system prompt. Let me actually show you one example. So if you come here, oh no, it's actually going to be up there as well. Let me. Yeah, so this is the one where we've got, the Discord chatbot, and we say, you are a helpful teaching assistant. Your task is to answer questions based on this, that, and that. And essentially, we give it that as the system prompt, and then the user query becomes the actual prompt combined with the chunks it retrieves. So when we've built this, we iterate on this prompt, for example. So we saw that it was a bit verbose originally, so we then included.
Yeah.
Yep.
So coming up with this system prompt is like quite an important piece of industry information. It's like a meta model that's really important.
Exactly, and that's why Anthropic doesn't want Claude system prompts leaked, right?
Yeah.
It's part of their moat, in fact. Yeah. But great question. And so other levers you have, right, are, let's go. You know, you can change your prompting that. You can also change your chunking in RAG and the embeddings and all of these types of things. So, yeah, I suppose I'll show this. Yeah, prompt engineering, embeddings, fine tuning, all of these types of things. Yeah. Oh, cool. Yeah. Yeah.
So I'm going to run to that, but.
Well, enjoy, and this will be online at some point. So, cool. Yeah, nice to meet you, Johannes.
It's a good language. What other languages do you want? Oh, if you know JavaScript, it's also a good language. Go try it out. Go try it out. Go for free.
We'll get started in 20 seconds, everyone.
How long more, sorry?
20 seconds. What do you want to do? You should go for it, and we'll. Yep. I definitely prefer that than. Hey, so everyone, Johannes, I think are you still here, Johannes, or you went to another talk? Johannes just came and spoke to me and had a wonderful question around, once we've identified failure modes and things that need fixes, how do we actually fix them, right? And there are lots of levers we have, and I think probably one of the most important ones is prompt engineering, depending on the system. So iterating on your prompt, on your system prompt, or whatever prompt you're sending to the LLM that combines the user's query. Of course, if you're doing RAG, iterating on your chunking strategies, embeddings, how you ingest PDFs is going to be, probably some of the highest lift you can get as well. Methods of last resort are things such as fine-tuning, although they're becoming easier and easier. Fine-tuning is becoming easier and easier because of the tools being developed. I do just want to show you, this is actually one of the system prompts for the RAG bot that we built for our course transcripts, and you can see it's a very basic one. You are a helpful teaching assistant. Your task is to answer questions based on the workshop transcript sections provided, be concise, yada, yada, yada. And originally it gave responses that were too long, okay? So we put at the end, the response should be short and concise, no more than 200 words. Now that resulted in shorter and more concise responses. It didn't necessarily do under 200 words because these things are horrible calculators. But the amount you can do with prompt engineering, or prompt alchemy as some of us like to call it, because I mean it's a wonderful tool. It's barely an engineering discipline. But the amount you can achieve with this type of thing is really serious. So for people who've built LLM powered apps, when starting your development process, how many prompts have you tried? So you've built something and tried 5? A lot, yeah. Cool. That's the correct answer. Anyone else? Let me see if I can find this. I do think it's under Pastor's GitHub, but let's see. He also built a bot which just takes conversations from Discord and summarizes them. Prompt engineering in the LLM. Okay, maybe I won't be able to find master summary. Okay, this doesn't actually say the number, but I can tell you in a second. We had a question in a Q&A about how much time should I spend optimizing a prompt to a production-ready state, okay? A lot of teams need 3 to 5 plus days to get a prompt that's really working in a robust way, not the couple of hours a lot of developers initially estimate. This includes proper testing, edge case handling, validation across different scenarios. One participant said, is there no option for more than 5 days? And the truth is it's an iterative process that is coupled with evaluation in a lot of respects. So it's something that is continually ongoing and requires maintenance. I can't find the numbers here, but we had people who'd ship something after trying 300 prompts, 500 prompts, 800 prompts. Someone I think tried like 3,500 prompts or something like that in order to get something that like worked for most of their cases. So that's just a sign of like how much you can achieve, but how challenging it can be with prompt engineering. And that will be one of your biggest levers. So what I want to talk about now is take you through a notebook of model evaluation. I'm actually going to take you through the notebook in the interest of time, as opposed to running the code, because some of the code is pretty takes a while because we're hitting a lot of different APIs, right? But the point of this notebook is to explore the process of using LLMs to extract structured information from LinkedIn profiles. Now, of course, we have JSON mode now, structured outputs, which tell an LLM to give you something structured. We're not going to be using that here for demonstration purposes. On top of that, at least anecdotally now, it seems that like getting structured output can happen at the expense of accuracy of the individual fields a lot of the time. So so let's say you ask, I want to get from this LinkedIn profile. Let's actually see what we do here. So we've got our imports and yeah, so this is a function where I give a prompt, extract the following structured information from the candidate's LinkedIn profile in JSON format, and I ask for name, current role, location, previous roles, education, and top skills. And if I do that, it will on average, at least in my experience, and a lot of other people's experience I know, provide less accurate responses than if I tried to get each one and parallelize them and then combine them into structured output myself, right? But there are trade-offs there as well. So what we do here is, and you can put, if you want to run this code, but it does take some time. So I just want to make sure the outputs are here, that's good. So to create a prompt, we're ingesting this LinkedIn profile and we're constructing a detailed prompt. And this is actually a prompt I iterated on several times. Look at this. So I say to it, do not include any backticks in the response, right? A lot of the time these models, when you ask for JSON, it will actually give it as like JSON in Markdown or something like that and give you these 3 backticks. Now, if you write do not include any backticks in the response, when I tested this, it reduced the number of times it included backticks by 50%, okay? Then when I said, you may think you're not including them, but you often do, treat the output as raw JSON and ensure it is valid, that reduced it another 50%, okay? So like, we're coaxing these things, right? Sometimes, and the jury's out, sometimes saying to it, please do this. I really want you to do this. Like, we need you to do this can help. Sergey Brin from Google, who works more than full-time now on Gemini, feels that threatening models get better results. But threatening with stuff like, I'm going to blow up Earth if you don't give me the correct result, and stuff like that. I do not suggest anyone does that. This is just Sergey who says this type of stuff. He also says threatening it with other things that I couldn't even speak, let alone dream. So once we have this prompt, and I've said be concise but complete. If any field is missing, return an empty array or field as appropriate. And I only figured out that that's what I wanted by iterating on this stuff, right? So that's the prompt. Then what I did is I created all the different chat functions. As we discussed earlier, OpenAI has a slightly different than Anthropic, than Grok, than Gemini. Just quickly, do people know Grok? G-R-O-Q? Oh, okay. I would actually encourage everyone to check it out, and I will put it in Slack. Sorry, I'm just looking at all the lols here as well. Great Wall of China was amazing. I stubbed my toe though. That's so true. So Grok is super cool. They have paid tiers now, but clearly the... Yeah, so it has a free tier for a lot of cool different models from, you know, Gemma models, Llama models, DeepSeek, like a whole bunch of open weight models that you can ping in order to get a vibe for what's happening. The other thing that, has anyone played around with AI Studio in Google? This is where you can get free, or like a free tier for Gemini as well. And it's a really nice interface. Google doesn't pay me for this. They do sponsor my course though, but that's because I actually love this stuff. One of the things I love about AI Studio is you can choose from all these different models and it tells you important information about the models, right? If anyone's used ChatGPT, of course, you know that the model naming conventions and knowing what's what is comical, right? The other cool thing that you can do here is you can iterate, you can prototype stuff, iterate on it, and then there's a get code button which allows you to copy and paste whatever code you have over to your system. And here, maybe I should teach part of this workshop in AI Studio, because being able to like adjust temperature, thinking mode, structured output, all of that type of stuff in a UI is super nice. So all that having been said, definitely check out Grok and AI Studio if you're interested. So what I've done here is I'm using OpenAI to chat with GPT 3.5, then I'm using Grok with Llama 3, then I'm using Anthropic with Claude 3 Haiku, and then Gemini with Gemini 1.5 Flash, okay? So Eric, I was just showing that, I mean, this is a toy example because we have structured output now, but how in terms of like prompt engineering or prompt alchemy, if I wanted structured output and to coax it to do it, I'd have to say stuff like, do not include any backticks in the response, because it will tend to do that. You may think you're not including them, but you often do, et cetera, right? And we really go through this process so many times. So then I was just testing with Stefan, my colleague who I developed this material with, just the Gemini chat response. And we see this looks pretty good to me. There's nothing standing out there. So in terms of thinking about our first steps towards basic evaluation, remember we wanted correctness, we wanted time, latency, we wanted cost, these types of things, right? So what I'm doing here is I've got a generate output function which is a wrapper around all these different models, right? And then what I want to do in terms of accuracy in this case, this is a toy example where I just want to know, is it actually JSON output or not? Is it giving me what I asked for, okay? So then I have this validate JSON, right? And what we see, right, with Llama 3 is that it's not valid JSON. And I was like, damn, okay. So I printed it, and even though I gave it the prompt, it still has 3 bloody backticks there, doesn't it? That's not a cuss word in Australia, by the way. It's a compliment. Got bloody steak. That's bloody good. Yeah, exactly. You're bloody great, Eric. Okay, and then I thought to check just Gemini, and it said it was valid JSON. So this is once again just getting a vibe. This is the vibe stuff, right? Now we want to make that a bit robust, a bit more robust, and I want to see how this works across different profiles, right? So I want to start logging things, and that's exactly what I do here. Now I'm not going to go through all the code, but I'll actually show you the output. I'm processing Stefan's profile across a variety of different models, and then I'm logging the latency and cost and results and that type of stuff. And we see the raw output for OpenAI there, valid JSON. We see the raw output for Llama 3, not valid JSON, right? We see the output for Anthropic, which looks like valid JSON. Ooh. Okay, for some reason it isn't. I don't want to dwell on that. Then for Gemini, valid JSON. And what I've done to log these things is to export this as a data frame. So we've got a column of the model name, then the raw response, That's what, yeah, the response for Anthropic started with, here is the structured information extracted from. Now, of course, you can deal with that after the fact if you know that that's the type of response you'll be. So once again, using Python as a judge or Python as logic, right? So we have raw response, then was it a validated response, and then execution time as well. So now we have a sense there. I want to start thinking about actually evaluating these models to see what I want to start building with, essentially. So once again, this is early days, but I want to evaluate these models on their ability to actually process these LinkedIn profiles, right? So the goal is to assess the performance of each model by measuring latency, validating output, and then preparing the results for further manual evaluation. And so what I do here is I go into this data directory and have a lot of different files, I think 5 actually different LinkedIn profiles, right? And what I do is I essentially run what I just ran across all these profiles, and in order to prepare for actually manually evaluating them. So, and I save them to this evaluation results with JSON validity. Great naming, CSV. And let's actually just have a look at this. No, I don't want rainbow. Right, so it's the profile, then the model, then the raw output, which we see here, latency, is valid JSON, and then correctness, okay? So we've got the latency, correctness there, and then the next one. So for each profile, I do each model, okay? And once we've done that, we take this CSV, and we're not going to go through this together, but we put it in a spreadsheet. And then we have a column, which is the output correct? Does it match expectations based on the profile content? And 0 if it's incorrect. And then create another column called notes, and use this to document any additional observations or findings that may be useful. And then we do it to each row and save the work. After that, I eyeballed the spreadsheet, and I'll actually show you figures from it in a second. But I eyeballed the spreadsheet and saw that models like OpenAI, GPT 3.5, Turbo, and Gemini generally outperformed in terms of correctness and JSON validity. Other models struggled with invalid JSON or low correctness score. From my notes, some models place multiple current roles under previous roles. If you have multiple current roles, right? Let's say you're an advisor somewhere now. Most systems will currently put whatever's listed as your first position in your current role, and then put your other ones under previous roles, right? So notes like this, and then latency concerns. And I'm not going to go through all this text now, but I'll show you in figures, right? So then we have the labeled data, the hand labeled data, which you can see in the GitHub repository. And we have 4 models, 5 profiles each. So we want 20 rows. That's exactly what we get. And we see here, just the head, we've got, this is Chris Wiggins, who is at Columbia and chief data scientist at New York Times. We can see this one was true for him, then false, then true, then this is me. He has several positions, so it had some current positions under previous role was my note there, right? And once I have this labeled data, with latency, and of course you want cost and that type of stuff, which we don't have here, but we can just look at a few plots, right? And look at this. So immediately we see that the Claude model we chose was correct 40% of the time. Gemini and OpenAI were correct 100% of the time in terms of giving me the structured output I wanted. And Llama failed every time. Now, of course, if you did have a preference for one of these models, you could go in and really look at the failure modes and see how you could change the prompt or something like that to fix it. But the writing's on the wall for me right now. When I was building this out, I was like, okay, at this point, I'm going to go with Gemini or ChatGPT, okay? So I don't know why I did correctness and no, correctness was slightly different to JSON validity. I'm sorry, I do need to go, because correctness was the fields actually correct as well. But then if we go into latency, right, what we see is that for some reason, Claude was like, I actually have no idea what was happening there. The rest are kind of, relatively similar, and the two that perform best on correctness look pretty samey to me there. And then just looking at all these metrics together, I need to make a choice. And essentially it came down at this point to between Gemini and ChatGPT, and because Gemini, they were priced around the same at that point in time, and Gemini had a free tier. So I decided to go with Gemini, okay? So that's really the calculus around in early stages, how to use these basic ideas of evaluation to think through what to choose. And this is on a model level, but then you can do the same like with your RAG chunks and all of these types, like change these levers, change the prompts and see what improves and what doesn't, right? And once again, in this case, we've got all the profiles, but you can use synthetic data and synthetic queries as well to see what's up. So next steps would be prompt refinement, so addressing the recurring issue where some current roles are misclassified under previous roles, then updating the prompt to explicitly state how multiple current roles should be handled, and then start to test at scale and document results as well. So, yeah, did we have a question? Okay. So what I then do, and you can go through this in your own time, and I'll speak to it briefly, but then I updated the prompt to include all ongoing roles under current role, excluding ongoing roles from previous roles, and so on. And you can see, literally, I've written, ensure all current roles are included in this section, even the candidate has multiple simultaneous roles, and so on. So this really speaks to the point that in this iterating on prompts is so important, and it feels weird as a scientist, or I refer to myself as a retired scientist, but it feels odd to be doing this. But I think that's one of the reasons why it was important that Andrej Karpathy, for example, would come out and say software 3.0 is programming in natural language. And he doesn't mean that in a flippant sense. He means that in a very serious and dangerous sense. I think that to improve these systems, we go in and update things using our mother tongue. I think that's very important to recognize. And so these are the updated prompts. Then I iterated on the prompts to capture detailed dates. The dates, start and end dates weren't great for their roles, so I iterated there. And then I ran the updated prompts on the full data set, and I don't want to go through all of that, but what I do want to go through then is, so you can have a look at the updated prompts and how the system improved over these updates. What I really wanted to talk about next is the potential flip-floppiness of these systems. So this is stochasticity or whatever we want to call it, but same inputs, different outputs. And if you've noticed so far, I've really only given an input once and looked at the output. So I haven't even started thinking about the possible distribution of results, right? You can lower temperature to ensure it's as little variability as possible, but you'll still get some. So then, and this is what I want you to not do with the API keys I gave you, but you can do the same query several times and then look at the distribution. So I actually want to scroll down to one example, and there's a lot of output here. Huge amount. So, yes. So I ran it, I think, 10 times for each LinkedIn profile using the same Gemini system, right? And then I thought I'm just going to print out the names. And we saw for Hamel, it's the same for each one, right? Then we saw for Chris, sometimes it's uppercase CW, other times it's lowercase CW. You may think that's odd, and it is, but Chris actually spells his name with lowercase C and W, but I think on LinkedIn, in one place it's uppercase for one reason or another, but he generally spells it lowercase, but that means we get this variability. And the rest, not much variability, okay? So in the name, there was an issue there, which maybe we'd want to fix. Maybe we just have a test afterwards which capitalizes or decapitalizes or something along those lines. What we're now doing is looking at the current role and seeing how it performs. So this is really interesting. So Hamel, the first is current role, independent consultant at Parlance Labs. Then the second is current role, and it gives a list of 3 roles. Then the second one just has a string, then a list, and so on. Similarly with Chris, we have all types of potential responses there. So even when we're making sure we're getting structured output, we're not getting the same thing all the time. How would you, depending what type of system you're trying to build, you could imagine that you expect this as a list or expect it as a string. So you actually need to write Python logic that will interpret it in a particular way. But given these different ways of that this system can output this, what would you think about correcting this or making it digestible further downstream? How about you, Eric?
I would choose, well, depending on the application, I would actually, seeing as this being structured outputs, I'd write a pedantic model that was explicit about whether current role is a single string or a list of strings. And so then that would allow me to control whether I get the array of strings, the list of strings as an output versus a single string as an output. Now, I couldn't control necessarily if it was a single string and it still spat out 3 roles in the single string. That would be hard, but at least there's a little bit more control over the downstream data types, which makes it easier for post-processing logistically. So I wouldn't have to write Python code that catches either string or list of strings.
So if it fails, do you go back and ask the LLM for another run, or do you just pick the first one and pass it through?
If it fails, actually, that's a good question. If it fails, it may fail because it didn't extract the correct role. Like, let's say I requested a single string, but then, and so it's supposed to be one role only, but it gave me the second to last role. That is a different problem from it gave me a string, but gave me like 3 concurrent roles at the same time, right? So yeah, concatenated roles. So those are different, those are even more granular failure modes for the LM that we need to put evals and checks around.
Absolutely. And I do think a mixture of, something like Pydantic to make sure you're getting out the types you want, which is a fantastic solution to part of this problem, and then downstream tests and guardrails and business logic and Python logic to make sure you're using what you think you're using. And we'll get to this in a bit, but this idea of, actually, this is a perfect time to introduce this. This is prompt chaining, right? And this is the example we're talking about where we're getting structured output from an LLM in order to generate an email with another LLM. Essentially, we have LinkedIn profile in, structured output out, then a gate. If it fails, we exit and we don't do anything. Or we repeat it. If it passes, then we generate the email, essentially. So we could even have a condition that if output doesn't look like this, we fail and need to try it again, essentially, right? Now, once again, you can go through this entire notebook, but I go through and look at the frequency of different outputs, and we see with Hamel, the name was 10, current role one thing occurred 5, another occurred once, another occurred 4 times, and this type of stuff will also allow you to iterate on the prompt as well. I'm wondering if I have a figure of all of this, and I don't think I do. But look, this is a long notebook with a lot of output, but the point really was to demonstrate how you can start with your basic evaluations across different dimensions in order to choose which components you're using, but then getting into the granularity of looking at the flip-floppy nature of it, and then how to start thinking about solving for that. So we had a question there, Eric.
So you were showing that flow chart before. When you go to fail, do you ever just say, that wasn't what I wanted, try again? Like, do you try a couple times, and then if it just can't get it, you're like, okay, fail?
Absolutely.
Is that kind of the idea?
In this case, I would, I think. The other thing you can do is, depending on cost and time considerations, like just do it 5 times in parallel, and if one succeeds, just choose that one as well. Exactly. Great question. So I hope this gives a sense of how to start thinking about evaluation and then downstream testing as well. And I'll find this. Stefan has a video on using PyTest through the types of tests you can downstream of this stuff in development and prod. So I'll find that and share it in the Slack channel. So I wouldn't be doing my job if I didn't talk about agents today. So I do want to talk about tool use and agentic workflows. Can someone tell me what an AI agent is?
It's a call to a tool with some instructions and a for loop, basically.
A call to a tool with some instructions and a for loop. Yeah, so that's how an engineer would define it. And I didn't mean that in any, what would an end user define an agent to be? We'll have someone else answer it, yeah.
Like an intern, basically.
Intern.
Right. Some agents can do more than some interns, I feel. But
Yeah, very similar. Our company is wanting us to think of them as virtual coworkers.
Okay.
cool. Yeah, so I don't disagree with either of those. I think those are perhaps examples. You could imagine like just an LLM is a virtual coworker as well, that you know, or an intern that you can bounce ideas off. So I think one way to think about agents at a very naive approximation is something that does something, that takes some sort of action, right? Whether it sends an email or creates a calendar event or pings an API or a database or something like that. Something that doesn't just return tokens. And we'll see how that plays out. And as I mentioned at the start of this tutorial, I do think, you know, a huge amount of value will be delivered by this type of automation. And I don't only mean like in a cynical sense, to be honest. I mean, a lot of the stuff that we have to do as knowledge workers, like all like the calendar invites kill me, right? And emailing and all of these things. I think if we did want to get more cynical, we could talk about the fact that a lot of emails will probably be LLM generated from bullet lists, bullet points, and then as email readers, we'll get our LLMs to turn them back into bullet points. So there's a huge amount of token waste in the middle. But that type of cynicism aside, I think it's important just to look at what happened over the past, 10 months or... No, this is only this year, actually. Thinking about deep research, DeepSeek came out, then OpenAI did a fast follow with deep research. Then Replit agents came out, and you may not think of Claude as agentic, but the example I showed you, I mean, you'd be hard-pressed to say, if I said, build a timer where I can set the time, and it generated this for me. It literally built and rendered useful software for me. You'd be hard pressed to tell me that that isn't agentic in some fashion, right? So there's just incredible movement in the space. I do also want to say, I wrote a blog post recently called Stop Building Agents, which the next part of this tutorial is along those lines, and it is build them only when needed and hesitantly, because there are a lot of other ways to solve the problems you want to build for first. But I do want to say, I also use agents all the time. So I think the idea of, so for example, when I was in Sydney, before I came over here, I was on the bus going to the beach. It was like 30 minutes or 40 minutes or something like that. And on the first half of the bus trip, I like built a Space Invaders game on my cell phone using Replit. And on the second half, I played it and it was cool and it was buggy or whatever. I never used it again, right? But I just spun something up, some form of ephemeral software to play around with in a small amount of time. That was fun. I've got a friend who built a chess tutoring app that, like, you wouldn't serve it to paying users necessarily, but he shared it with 50 friends or something, all of whom find it useful to various extents. And Eric and I were talking about this over breakfast yesterday. Eric found it such an interesting conversation, he put microphones on us and recorded it. So we may put our breakfast conversation out as a podcast soon, but leave in the parts where we're talking about the salmon frittata. But part of this conversation was around how I think the surface area of software is increasing so much. And I think, once again, to get a bit big picture, classically, software has been very expensive to build because you need to pay a bunch of engineers significant money to build it. Because of that, you need to get a lot of users to fund the building and the business model. Because you need a lot of users, you need to cover a lot of edge cases. So it means software has to satisfy a lot of different requirements, right? Whereas now, with the ability for all of us to spin up things for us, our colleagues, our friends, whatever it may be, it actually changes the entire game of what software can be. So I think that's very exciting. Now, but that's not what we're talking about today. We're talking about building reliable, consistent software and starting to use agentic approaches. So the statement is, the question is, LLMs can generate text, but can they take action? And what type of action do we want them to take? We want them to be able to automate workflows. We want them, like one of my favorite things would be like to have if we're on a Zoom call and we set up our next meeting, for the transcription bot to just set up that meeting so we don't have to do all that calendar stuff. Just because I work across time zones, but that's more about me. We want them to be able to interact with external systems, such as databases and APIs. We want LLMs to be able to perform calculations. Isn't that funny, that we want them to act as calculators, because they're horrible at calculation? And I love this example because it reminds us that a lot of our expectations are subverted by LLMs, that they're horrible at calculations. Now, it's actually not straightforward to figure out how to get an LLM to perform calculations. So can someone tell me, like, what's one obvious way to get an LLM to robustly perform calculations?
Have it write code for you.
Have it write code. So Python code, for example, right? So have an LLM write Python code and then execute it. So did you have another suggestion?
I would imagine that Wolfram Alpha has a lot to say on this.
So that's a relatively abstract statement. Can you say more?
Okay. So I listened to a podcast by Stephen Wolfram. He separated the LLMs right now as they're sort of mashing knowledge, how to speak language, like the mechanics of just putting one word after another, knowledge retrieval, and talking to databases. They're sort of mashing it all into one model. He said, let's separate that into three different things. So we can have a tool to query to say, what's 3 times 5 as numbers, and then feed that into, say, a model to chain the English words together to say 3 times 5 is 15.
That makes a lot of sense to me, and it does speak to your solution as well. Whereas we have, let's keep the conversation going.
I think we're all circling the same thing, but I think I was confused when you said when you didn't jump on the Python writing the code and execute it, right? Like, to me, it doesn't make sense how predicting the next word is ever going to carry out a calculation. That just, right? Like, how do you score a three-pointer in a football game? Or am I missing something?
Well, I think the point is that LLMs are generally trained on so much code that they have calculator code in their training data. So it's actually quite easy for them to write Python code that can calculate.
You did it with your timer earlier, right?
Exactly. So, and that was sandbox. So my concern is I would never execute arbitrary Python code on my local file system that an LLM has just generated, right? So suddenly we need to sandbox these things, right? So getting an LLM to actually perform as a calculator is highly non-trivial. Hey.
Could I just fine-tune the LLM some way such that it only performs calculations instead of doing everything plus calculations? Like,
why wouldn't you just use a calculator though?
I don't know, because you want the LLM to calculate stuff. So I guess it goes back to their point of why, why don't you just use a calculator? That's a great point.
So, I actually meant why don't you just use an LLM with a tool call to a calculator? I would avoid fine-tune. So what would you fine-tune on?
I don't know, but you could just take take 5 minutes to build a custom GPT and then be like, your only task is to perform calculations. Don't give me anything else. And it does a very good job of being good at math. If you just sort of pre-tune it to be like, your only job is to be good at math.
I want to clarify something there. That's not fine-tuning.
Oh, sorry.
That's actually LLM steering by setting the system prompt. When you build a custom GPT, you're not fine-tuning the GPT. You're not fine-tuning any of the GPT-3 or GPT-4 models. You're merely setting the system prompt to steer the LLM in a certain direction, and those are only soft guardrails. You can break the system prompt and get it to not do calculations still. It is possible, probably hard, but it's still possible. Yeah.
I've been playing around with LLMs for math for a long time, and I've seen the evolution. So originally it was, the newer OpenAI models were absolutely terrible. But over the past year, I enrolled in some MOOCs and was trying to do mathematical proofs, just asking advanced number theory and just different types of advanced math. And it was getting the answer in paragraph form with an explanation of why something worked more often than it didn't. So I don't know everything what's going on behind the scenes, like what OpenAI is doing, but it appears that whatever reasoning that they have in the base model, that it is having significant improvements with each new model.
Yeah, I've actually seen models that are quite good at advanced, like algebraic geometry proofs, but are still horrible at arithmetic. For what that's worth. One more, and then we'll move on.
I'm trying to avoid navel gazing too much, but would it improve on my previous answer of generating code, and would it improve on your timer and your Space Invaders game for the agentic action to funnel you to an existing tool that exists out in the world, right? To feed you to something that serves this purpose and is validated? Because isn't there always a risk that it's going to be wrong?
Well, yeah, but I actually love your original answer. I would just sandbox it. I think that's the right way to do it, is to get it to generate Python code that then you just sandbox. I think that's the best way to get an LLM to perform robust arithmetic. It's the best way I've found anyway. Yeah. And that's somewhat analogous to, like, you are using a tool there, right? Yep.
But there are calculators that exist, right? There are calculators and timers and Space Invader games that exist on the internet for you to trivially get to and use. And the act of generating the Python code does introduce a step that gives you risk that you are causing some faulty behavior.
Yeah, but I think my point is that any tool call would be the same, right?
What do you mean by that?
Well, there's still a risk that it will perform the incorrect. It will give.
I guess that's sort of cosmically true. Yeah.
Yeah.
We trust that when you type in a math equation into Google or Wolfram Alpha, that they have some reason to believe that their process is valid. Versus, I guess my argument would be that generating it via LLM, kind of like the parsing we've been doing, right? I was thinking about whether this implies that there's a large suite of tasks where you start building with an LLM-driven application and you realize I should have used traditional code for this the whole time, right? There's all these edge cases that are really, really difficult to handle. And even in asking an LLM to generate the code for you, it's likely to make mistakes about that. And you're spending an amount of effort that would have been better served to just do this parsing of a PDF from scratch using traditional Python. So would it be better for agents to be able to, or for LLMs, to be able to funnel you to these tools rather than building everything synthetically from its knowledge base?
Yeah, I think depending on the complexity of it. So for a calculator like plus, minus, addition, multiplication, division, writing those things in Python code is pretty straightforward. But where it's significantly more complex, and I think you're absolutely right. That's one of the things that MCP kind of helps us with as well. It gives us a unified interface for interacting with external tools. So I like that a lot. So to move on though, we've talked about all these things, but what do we want, quote unquote, LLMs to be able to do, right? We want them to be able to retrieve information, run code, use tools, handle multi-step tasks, trigger actions, so activate appropriate strategies, tools, or next steps based on context or inputs. And I just want to make clear that ChatGPT, let me just actually, hey ChatGPT, I'm at the SciPy 2025 conference, tell me about it. So ChatGPT is searching the internet, and I didn't ask it to, right? So it's already got agentic behavior baked into it in some sense. And it can, SciPy wants to update all of their marketing material, including new images and copy for the next 50 years. Can you give me copy and new images? Didn't even SciPy. Okay, we'll see what happens there. But my only point is that it does web search, it creates images, all of these different things. So it is agentic in some sense of the word agentic, right? So this may take a second. We'll come back to that and see what's up there. I did, didn't I? I don't know why I would have done that. But this all really speaks to the point that we're jumping to something quite significant without taking perhaps some intermediate steps. So late last year in December, Barry Zhang and Eric Schlutz, is that his name, at Anthropic published a blog post called Building Effective AI Agents. Is that what it was? Just a sec. Building Effective Agents? Yeah, Building Effective Agents. And it was something we were all kind of grappling with at the time. That before we're building agents, we're starting to build workflows, and they came out and showed us what the most common patterns that they've seen in people using Claude in terms of building enterprise software, right? So I love that they first said, hey, let's just step back and think about, before we even do tool call, agentic stuff, let's think about how we're augmenting text in and text out. So we've already talked about this, right? We start with memory, okay? Then maybe we have some retrieval via RAG, which we've talked about as well. Then we have tool calls, right? So, creating a calculator, or these types of things, or having a SQL query tool, right? And all of these things are kind of on the path to agents, right? And they demonstrated a set of patterns, which I'll take you through some of the code for soon, where these were the common patterns they saw, such as chaining different calls, then routing different calls. So you could imagine, I think the case we'll look at is if your LinkedIn profile, if the LinkedIn profile is a particular type of profile, maybe you take it down a particular path. If it's another one, you take it down another one, right? The orchestrator pattern is slightly different, where we have these things do stuff in parallel and then it's synthesized, whereas the router sends it to one. And then we have the evaluator optimizer pattern, which is getting perhaps a bit more towards what we would think of as a full-blown agent, where we have a solution generated by the generator. So you could imagine this is an outreach email based on a LinkedIn profile, right? And then an evaluator decides whether it's good enough or not. If it's accepted, goes out. If it's rejected with feedback, then we continue. Maybe you want this to break after 5 iterations or something like that. But these are the types of patterns that they really saw emerge. And actually, maybe it's time then to jump into. That's the new logo for SciPy, everyone. Yeah, amazing. Well, that's what we need. We need an agent like connected to a 3D printer to make T-shirts or something like that, right? That's wild. That's why I also like the term artificial stupidity as well. So, yeah, let's now. Okay, this will take a second because it's going to. So maybe can you put up your hand if you've used function calling before? Okay, we have a couple of people, so maybe it's worthwhile just showing a little toy example of this, which we can do in Notebook 3. And it's quite wacky, isn't it, Eric, kind of the workflow for function calling, in that the LLM generates output and it doesn't call the tool, but then you figure out how to use that output to call it.
That's right. So actually with function calling, the pattern isn't that the LLM itself is executing a function. It's actually generating arguments to a function. And then we take those arguments and then we decide, okay, we should execute that function within our main Python program loop. And so I was explaining to Matthew Fiker here as well over Slack that I think is knowledge that should be shared with everyone. Olama itself may list models that are capable of tool calling. And what that actually means is it's capable of it's been trained specifically to generate arguments to functions, both args and kwargs. And that we, as humans, we as the designer of the agent can then use that as part of the execution workflow downstream.
Absolutely appreciate all of that, Eric. So, and we'll see that exactly now, where we're going to have a toy example of using an LLM to call a weather API to see. So what we do is we define the function structure for the model, as we'll see. We'll let the model, so that's for the tool call, we'll let the model quote unquote decide when to use it, and I don't really like the word decide there, but the output will either trigger it or not, and then we explicitly execute the function ourselves with the model's parameters. Then we feed the result back to the model. So we actually get, it's 2 generative responses, right, Eric?
Sorry, what was that again?
We actually ping the model twice, one to get the function call and then the next to get the response.
That's right. So you generate first the arguments, then you execute the function and capture the outputs, feed it back to the LLM, and then you do a second call to get the actual response for the task that it was supposed to run.
Exactly. So let's now see that in action. So if you put your OpenAI key in that first cell, then we're going to use requests to ping get weather API, where we put in the latitude and longitude, right? That's what this get weather function, the arguments it takes. Now we're defining the tool for OpenAI, and we're telling it the function. We're telling it in the description, get current temperature for provided coordinates. I'm asking it in Celsius because those are the correct units. And I'm telling it the properties are latitude and longitude, right? So that's what I'm giving to the model. And so I love this example because when I say to the model, what's the weather like in Sydney today? Let's do that. Take a second. Then I look at the completion, and it's recognized it has a tool called get weather, and it can use that. So it hasn't just hallucinated. It said, I'm going to use a tool call, essentially. It tells me it's going to use a tool call. It says what the name of the tool is, get weather, and it gives the arguments, right? And here it actually gives the latitude and longitude. So it was quote unquote smart enough or able to recognize that Sydney needed to be converted into this latitude and longitude, right? And it's a function. And so then what we do is I'm pulling out this tool call and the arguments, and then I'm converting putting the arguments into get weather and save it in result. And then what I do is, once again, I feed this back into the model with the result of the tool call, and we see now the result, where did this? Yep. The current temperature in Sydney is 12.2 degrees Celsius, right? So that's the pattern of asking the LLM, prompting the LLM, and then its output dictates whether it accesses a tool or not. Then you use the tool to get the result and feed that back in to the LLM and get the generative response. There's a nice, it's 14 according to Google. Okay, well.
I also cross-checked latitude and longitude, so that at least was correct.
Yep. Yeah. Okay, great.
Always do your evals.
That's right. And I'm just trying to, let me see if I may not, oh no, it's one of Ravin's. I am going to try to find this is our friend Bayesian, and also works at DeepMind now. And we have done a bunch of online workshops on tool calling, and he had a nice image from Gemini that just shows, oh yeah, it's nice because it's horrible, right? So this is the tool, this is the function calling flow, right? Where you have an input, a prompt, then decides whether to respond. It may give an answer. If not, it will, oh wait, is that? Yeah, so then it will return the function name and argument if it's doing a tool call. Then we need to do this or automate actually parsing the response, executing the function, then sending it back to the generative model, and then using that to complete the completion endpoint, essentially. So this is a nice but understandably ugly, illustratively ugly diagram of the passes we're taking in order to do this. We've got a question up back, Eric. While you're heading up there, Eric, I will say another thing worth thinking about. I've got a lot of colleagues and friends who build stuff for customer service, conversational agents, and they're thinking through a paradigm currently called process calling, which is kind of function calling or tool calling is a particular case of it. It's best illustrated via example. If someone says to a customer service chatbot, I lost my credit card, right? Like they don't care whether a tool is called or a function is called, and it will probably take several different function calls in order to get the correct credit card sent out to the right person. But what you really want is a process to be called, the process of get this new credit card to this person, and then within that process call, whatever function calls necessary are taken. So in many ways, process calling is a nicer abstraction layer for the types of things we want to build than mere function calling. But the space is evolving quite quickly. So we have a question up the back.
Thank you. So in this example that I have provided for this tool, we have it accepts latitude and longitude. Then you ask the question given the city name. So how does the model is using the pre-trained model to get the latitude and longitude, I assume, right?
Exactly. So you give, what the model gets is your prompt, which is what's the weather in Sydney, and it also gets the information about the tool call, right? And so what it does is, I'm trying to not anthropomorphize here, but it recognizes that it needs to convert Sydney into latitude and longitude because those are the arguments the tool accepts, and because it has that knowledge in its training data, it does that.
Yeah, in this case, there is no guarantee that it actually the conversion is correct or.
Well, yeah, you do need to check that, yeah. Absolutely. But in this case, it looked pretty good to me. I know the latitude of Sydney is around that. I don't know what the longitude is.
Okay, that's nice. It's not curious how it's taking leverage of all pre-trained data to come up with the conversion automatically.
What's that, sorry?
I'm just curious, I was curious about how the model used the pre-trained knowledge to come up with this conversion, right?
From location to latitude and
from
longitude?
From Sydney to latitude and longitude.
Yeah, so let's be careful.
They don't have a tool for making this conversion here, right?
Yeah, I definitely think I would, if someone told me that there was enough data about cities and latitudes and longitudes in, the sum of human knowledge on the internet, I'd believe that, right? I do think that the training data is important here. I wouldn't discount what happens in post-training as well. I do think that representation in the training data here is probably strong enough for it to be cool. Got another question up here.
Up front, where?
Yep, just wait for the mic, yeah, just up here.
So in this case, the tool, at least from what I understand, is the API tool that we're using. And so in that case, what other types of tools can we make use of apart from just the API?
It's a great question. So you can build all types of tools and interact with all types of APIs as well. But there are email assistant tools, calendarization tools. You can build calculator tools. All types of things.
I think the key, Hugo, if you scrolled up just a little bit, the key here is that you have to expose the tool in JSON format, right? So the tools equals this list of dictionaries, basically, and you have to be able to expose that to the LLM via the API. And so the get weather function, we happen to have it defined, and so then we can pass, we can, if we have that defined in Python, for example, there is a way to automatically convert this into this JSON format, which you can then dump into the API call. So I think the easiest way for those of us who are programmers to think about it is if you have a Python function and you've got args and kwargs, if you can convert it into that JSON, you're gold. You can provide that as a tool that is available to be called on.
Exactly, and I just want to give one example. I've just put this blog post that I did, the Stop Building Agents one. This is an agent that I built a while ago that I use all the time, and we use in the course actually. It's a basic data science agent, which I actually think is one of the best uses for agentic stuff, where I have 3 tools. I have a SQL query tool, a data analysis tool, and a data visualization tool, okay, which I define myself, right? And then I expose them as tools for the LLM to have access to, essentially.
So does that mean that you need to be able to break down like a certain tool that you're working with? Like, for example, if it's like, are you able to use like a tool that is specifically for software, like designing software or something like that? Like Adobe, like editor or something like that. If it's that kind of tool, are you able to use an LLM to utilize that tool specifically?
Not necessarily, and that's one of the reasons, and we're not getting into this too much today, but that's one of the reasons something like MCP, which is, it's Model Context Protocol that came out of Anthropic, and essentially you can think of it as like Bluetooth for software and APIs and that type of stuff. The idea is to have a unified interface for LLMs to interact with different types of tools. So if Adobe had built something which you can write as a Python function or connect to the Model Context Protocol, absolutely. But here we're really talking about tools that you can define through Python code or APIs that you can access with Python code. Would you alter anything to that, Eric? Or? But I think the future of what you're talking about is absolutely massive. And going to be increasingly important. So I won't go through the rest of this notebook. I'll move on to the multi-LLMs one, which is really looking at the types of patterns that we've been talking about with respect to the Anthropic blog post. And we're going to start with 3 foundational workflow types. Okay, and we'll execute this code. But the first is what we've been talking about, prompt chaining. So decomposing a task into sequential steps, where each step builds on the results of the previous one. Parallelization, distributing independent subtasks across multiple LLMs for concurrent processing. And then routing, which dynamically selects specialized LLM paths based on input characteristics. Now, one of the reasons this matters, so single LLM calls can't solve a lot of complex problems, right? Because they require multiple steps and different steps. So think about content moderation. I actually don't think, I understand why we need to, but we should be very careful about how we outsource content moderation to machines. But effectively moderating content requires a lot of different checks, right? For customer service, you need to understand queries, route them to specialists, generate responses. For quality assurance, QA, you need validation, refinement, all types of things, right? So we do usually have sequential steps or things in parallel, and getting one LLM or one process to do them, there are so many failure modes. So think about, I think state-of-the-art function tool calling gets it right like 85 or 90% of the time or something. If you have 4 or 5 steps in a row, you can do the math and it's a coin flip whether you're going to get the correct result, right? So making sure you break it up into identifiable, robust subtasks is incredibly important. So,
65%. If it's 90% probability to the power of 4.
Great, thank you. Did you call your LLM tool?
Google.
Yeah.
Google.
Is that the AI overview though, Eric? I'm just kidding. I'm not actually, but so let's just have a look at an example of this prompt chaining, right? So when would you use this? When a task naturally breaks down into sequential steps, when each step's output feeds into the next, and when you need clear intermediate results, and when order of operations matter. So like to the example of generating emails based on LinkedIn profiles, this is a perfect use case where you get one LLM doing structured output, making sure that works, then if it's all good, generating an email based on it. So let's actually just have a look at this. So we have, this is our chain function, which will chain two functions together. We have our extract structured data, which will extract it from a LinkedIn profile. And then we have a generate outreach email, where we generate professional outreach email using the structured data. And so I'm going to execute that. And then what I'm going to do is I've got a fake LinkedIn profile, someone called Bowne-Anderson. I don't know if you ever saw Mr. Robot, but he was the main character in that. He was a cybersecurity engineer specializing in penetration testing, network security, and ethical hacking, and so on. So what we're doing is we're taking these two, and step 1, we're extracting the data, and we're not doing any checks, right? You would want to test it. And if it fails, like actually move on or try it again. And what we see here is we have a generated outreach email. Great. Potential cybersecurity collaboration potential. Dear Elliot, I hope this email finds you well. I'm reaching out after reviewing your impressive background, your expertise. Okay. I mean, it's not as bad as like some actual outreach emails pre-LLMs, to be honest, right? I don't know if you'll like get people on LinkedIn coming at you, but wowza. I've even had ones which are like best regards your name, to be honest. So, but that kind of looks okay, right? And just some key takeaways from this. Chain LLM calls when tasks naturally break down into sequential steps. You do want clear and structured output for the next step, and definitely consider error handling and even, gates which will give you a fail if certain conditions aren't satisfied. And just some gotchas, avoid chains that are too long. Always ensure each step's output format matches the next step's input expectations. This is a wonderful reason for structured output as well, right? And also watch for context loss and information loss between steps. Now, in this notebook, I go through a variety of the other examples, and I don't want to go through all of them right now, because, there are examples we've talked about, and you can go through them, but I do want to go through the evaluator optimizer example. And this, let's see if we can get there. So this is the one where we have a generation process, then an evaluation process, right? And we either have it accepted or rejected with feedback. And so we have a generator which produces the initial output, such as a draft email or translation, and provides the starting point for the evaluator's analysis. The evaluator reviews the output and compares it against predefined criteria as well, and then identifies areas for improvement and suggests refinement. So in this example, we'll be improving the outreach email for professionalism and tone. So the input is an email drafted from a LinkedIn profile. The generator creates it, the evaluator reviews for clarity. So let's have a look at this. So we have the generate an email based on the LinkedIn profile, and we have the one before from Bowne-Anderson, and then we have please review the following email and provide feedback. The goal is to ensure it is professional, clear, and maintains a warm tone. If it needs improvement, provide suggestions. And then we have the optimizer function, which is based on the following feedback, improve the email, ensure it remains professional and clear while implementing the suggested changes. And we orchestrate it. And so what I'm doing here is I'm doing a single loop, okay? What I'm doing is I'm generating the email, then I'm evaluating and sending it back, and then returning that. So this is a simple, like one loop there. And of course, you can have a while or whatever to send it back and forth and that type of stuff. I actually think one challenge we have there is the issue of the LLM eternal optimizer. Have you had this, Eric, where you, as I mentioned before, I will use LLMs to draft, copy for a podcast landing page or an event or something like that. And I'll work with it, then I'll make a few corrections, work with it again. And even if it said, this is great, you give it to it again, and it will constantly bike shit, essentially. It will, even if it has generated something saying this is the final version, and it will often say this is the final version, you're good to go, and you'll paste it back in, and it'll be like, hey, this comma should, So the eternal optimizer can actually be very challenging. So, and this is a concern with these types of loops as well. So let's just do one pass and see what happens here. So processing LinkedIn profile. Okay. Dear Elliot, I hope this email finds you well. I'm reaching out after carefully reviewing your impressive professional background and I'm genuinely excited. I'm sure you are. Great. Okay, we've got all of that. And let's look at, wait a second. Okay. I'm sorry. Yep. So this is the first version, right? Then the evaluator feedback. After reviewing the email, I find it to be quite strong overall. That's nice. It demonstrates professionalism, personalization, and a genuine interest in the candidate. However, I have a few minor suggestions to enhance it. Add a specific reference to the company's cybersecurity initiatives. Consider slightly softening the language. And then, okay, this is interesting. So I'm sorry for scrolling around a bit, but I just want to make sure. This is interesting. So the prompt was, please review the following email and provide feedback, right? What it has actually done is it has not only provided feedback, but it has actually even provided a new copy of the email, which we didn't ask for. So maybe we'd want to iterate on that and say, do not redraft it, just give feedback. And it may still do that because, but now it's added all the things that it's asked for, and then it says the key improvements, and then we have the final optimized email, which has included a variety of these things as well. And actually, this is horrible, right? Look what it's done. The generated email at the end, because the evaluator said, and I haven't encountered this error failure mode before actually, said, this is the new email, key improvements, and the final generated email has the email and then says key improvements at the bottom, right? So it includes all the feedback, which is not what we want at all, right? It almost reminds me of, did you see I can't remember what Elsevier journal it was, but the abstract started off with, here is the final version of your abstract, dear user, or something along those lines. So this is fascinating. So there are already obvious ways to start thinking about prompt engineering to improve this. And funnily, I've run this cell more times than I care to consider, and I actually haven't seen this failure mode before. So, and that's a reason we probably don't even want to do more iteration with this, but iterate on this loop, but actually improve the prompts. So those are some of the patterns that we want to use before going full-blown agents. And let me just say, putting the cart before the horse, so to speak, just to give a heuristic about when to use what, when to use an LLM, when to use an augmented LLM or an agent. If you just want to generate text, use an LLM. If you want to retrieve external information or use APIs or tools, or you do predefined multi-step tasks and tool calls, use an augmented LLM. Now, if for some reason you want your LLM's output to define what tools are being used a lot or adapt the workflow dynamically, do use an agent, but just buyer beware. And I think these situations are best when you have a human in the loop in a pretty robust way. So the whole point is you need quality checks somewhere, right? And if you're using an agent, a full-blown agent, the quality checks aren't in the software. So you need a human in the loop there. And that's why agentic AI-assisted coding is something that I think is powerful, although it can be infuriating. And similarly, why having a data science or data analyst agent can be really useful because I'm there in the loop with it. Or you can think about even an AI agent assistant for a doctor that helps them with patient records and find information, prescriptions, whatever it may be. But you wouldn't want it to write a script and give the medication to the patient without the doctor saying, yes, that's the correct thing, right? So having a human in the loop in the right way is super important. I did want to talk a bit about multi-agent systems because I get a lot of questions about this type of stuff. Especially when I tell people don't build agents, they're like, oh, but Crew AI is really cool. I'm like, yeah, it absolutely is, and it's a lot of fun. And I think I'm of two minds about this because once again, I think these things are very powerful, but they don't result in reliable, consistent software. One thing to note as well is that there are other cases where you don't want consistent software. You want it to be reliable, but you don't want it to be consistent. You can imagine a research analyst, right? If you wanted to have an AI agent that was a research analyst that goes out and collects a lot of different information, brings it back to you in a particular format. let's say you wanted to send it out 10 times, right, in order to get different information. You actually want it to come back with 10 different types of things so that you yourself can have a look and see what's up there. So there are a lot of use cases where this type of stuff can be powerful. But I just want to show you an example of something I built with Crew AI that and the failure modes that happen here. So if you don't have experience with Crew AI, that's totally cool. You essentially, in your root directory, define your agents and tasks and then the tools they use, okay? So I defined one where I had a senior data researcher. Their goal was to uncover cutting edge developments in a topic, which you specify later, their backstory, their task was to conduct a thorough research about a topic. And then I said, make sure you find any interesting and relevant information given the current year is so-and-so. Expected output is a list with 10 bullet points of the most relevant information. And this is the basic way to create a crew. Then this may be, oh no, you can see that I think. I'm going to share the slides afterwards, but you create the crew base, you create the researcher agent, you create the research task, and then bring it all together in the crew, and then you can run the crew. And I said the topic was Hugo, current year was so-and-so. Once again, I did that in the spirit of making sure that I could evaluate. Now, that's all well and good, okay? But if we're starting to think about multi-agent systems with stuff such as Crew AI, you can see here I've given it a research task to, can people read that or kind of? I'm actually going to take a screenshot and put it in Slack as well and then talk you through it. But essentially what I did was I asked this agent to conduct a thorough comparison between two items with a particular goal, okay? And in a second I'll tell you which ones I chose. I said first, use SERPA dev tool to search the web to gather relevant articles. I asked for it to search for item 1 independently, item 2 independently, and then search for comparisons between item 1 and item 2. So how many tool calls am I asking for it to do there? 3, right? Item 1 independently, item 2 independently, then both, okay? Then I asked for it to do the same with Tavily search tool, so another 3. Then I asked for it to do the same using Reddit Tavily search tool. So there are 3 more tool calls, right? So I'm asking for 9 tool calls, okay? And what actually happened was, this is a span graph, and this is when you have, like, I think more intricate systems, having these types of graphs. I think that this is, yeah, I did this in LangFuse. This essentially tells us what's being called and when over what time frame, right? So we can see the crew kicks off, crew's created, task executed, and then we get into the chat completions, and then we get the tool usage. And you'll actually see that we have 1, 2, 3, 4 tool usages, right? So this system did 4 tool usages and gave me a response, which wasn't bad. But the fact that it only did 4 out of 9, and I think I ran this 20 times and I never got all 9 function calls. I think I got 7 was the maximum, but most were around 4, 5, and 6. So this is just a basic demonstration that if we're trying to rely on LLMs in the first place, that can be challenging in itself. But if we're trying to rely on them to execute a bunch of tasks that we need done, particularly when we get to a certain number, it's very unlikely that it's going to be able to get to all of them, which is why we really want to think more about building robust workflows. So yeah, to wrap up, I do want to say, I've said this before, when to use an agent, augmented LLM, or LLM. I suppose there's another figure with the explosion here. If you just need text, use an LLM, right? If you need to interact with tools, external tools, do you need the system to control the workflow dynamically? If not, use an augmented LLM, and if so, use an agent, but buyer beware, right? And as I said, I do think they're incredibly useful when we have humans in the loop in the right ways. But if we're building software for people to use externally, like client-facing, customer-facing, we definitely want to be very mindful, but even internally as well, depending on what the use case is. And we've gone to GitHub and looked at all of those things, and so I think that's pretty much all I wanted to present. We've got around 15 minutes left, so I'd love to just open the floor for questions or reflections or thoughts, and even hear on what you're building or what you think you'd like to go and build after this workshop also.
Yeah, thank you for this presentation. I want your elevator pitch on agent-to-agent protocols, MCP, just a few words.
Yeah. My elevator pitch is wow. I mean, like, what exciting, no, seriously though, like what an exciting space, right? It feels so, I grew up, I was a teenager in the mid to late 90s, so I don't really remember what the early web space looked like, but I get the feeling like, kind of like this, like a space of exploration and fascination and things bubbling up and wow, what is this? It doesn't mean anything's reliable though, right? So the short answer is very exciting. Longer answer is I don't really see much reliability or current usability happening there. I think the future is very bright though. Let me bring up a slide. So on MCP, so I will say a few things about MCP. As I said, it's a unified interface to, sorry, this is from another talk I gave recently, to expose tools and resources to applications, right? So before MCP, all of these unique APIs, you had to like wrangle and write different function calls, and we just saw the weather API and that type of stuff. After MCP, you've got this unified API, which allows us all to, although as I said before, I think Slack has pulled back from MCP. Open protocol that standardizes how applications provide context to LLMs, like a USB-C port for AI applications. So I wanted to get to this. One of the reasons I'm so excited at this wild space is like the community rallied around MCP, which was built by Anthropic. OpenAI's adopted it, Microsoft, Google DeepMind. Like that's almost unheard of in this space where these companies aren't even frenemies, right? Like this is war in a lot of ways. So to see this adoption here, I think is fantastic. If you want to get started, definitely check out the Model Context Protocol website. They've got some cool ways to get started. I do want to say, I think I kind of joked about this in Eric's tutorial yesterday. There may be a future in which the internet isn't human readable, right? I wouldn't be necessarily surprised if at some point in the medium term, a lot of the internet was designed for agents and for LLMs and not for humans. So we already see LLMs.txt files. This is a website, right? That, tells you about agents and that type of stuff. This is another one. You should check out Gina. It will turn any website pretty much into an LLMs.txt file, right? But this is a web page which is somewhat human readable because it's text, but you can see it's actually designed for LLMs to read. So I wouldn't necessarily be surprised if in the medium term there are a lot of things out there which are agents interacting with agents far more efficiently than having things that are human readable for agents and LLMs to look at. Another example is, I don't know if you've used Operator, for example, from OpenAI. So it's an agent that will do a bunch of things, including like search the web for you. And I asked it to like find some shoes for me in Sydney. I've got ridiculously large feet, and I used to actually buy shoes at a shop called Bigfoot, which closed down because they didn't get enough business. But I literally said to Operator, I want you to find shoes in Sydney that are size 17, blah, 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 blah. And it spent 10 minutes searching the internet, right? And I've got the screencast of it. And eventually it found, like in the van store, it clicked through and found this. The reason I'm telling this long-winded story is watching this agent do that felt so dumb. Watching an AI agent like Selenium style, like point and click around websites felt like the most inefficient way for an LLM with agentic capabilities to search the internet, right? So I think there is a huge future where all of these things are designed more for agents than for us. Sorry, that was a very long answer, but I hope that wasn't an elevator pitch. It was more like a rocket ship.
A to A down, MCP up?
Well, they're different things. A to A is for agent to agent, and MCP is for agent to interact with external services. Yeah, so I don't think they're mutually exclusive. I think they're complementary.
So with this question, I want to go back to your previous slide where you said, so go for agent, and then you said in the hint, probably not. I find it little contrasting statements. Can you expand on that? Like how, from LLM side, you're saying, if function calling can help, then we should not go for agent. But at the same time, if agents can do the stuff that's required to do, then why not? So,
yeah, my only point, I think, is that if you're relying on an LLM, the output of the LLM to arbitrarily trigger a bunch of different, or choose a bunch of different function calls, there'll be a lot of failure modes, as opposed to merely just augmenting with a single tool call or two.
Thank you. So I'd like to know, if possible, based on your experience, what is the go-to, if you have any go-to frameworks specific for model evaluation, talking about large language models, model orchestration, I have shown some, and also model monitoring and debugging. So do you have like recommendations, or what do you use the most?
So you're asking about evaluation, orchestration, and?
Monitoring or debugging.
Monitoring.
Yep.
Okay, so I'll just change the question slightly. We don't necessarily want model evaluation. We want like AI system evaluation, right? What's that?
In my mind, I can think something like Raga is for evaluating RAG applications, or Deep Eval, this kind of Python frameworks that you use, if you use any. I'm just like curious about your.
Yeah. So let me just show you something, and I don't want to avoid the. So what I want to say is there are lots of great frameworks out there. What I do and what I see a lot of people do is hand roll a lot of things internally, and then adopt frameworks and modulate them and build things on top of them, because none of these frameworks satisfy all the things we need to do. What I want us to do is avoid, let me just show you, where is this? I've got, no, that's not it. Bear with me. No, I'm sorry.
Hugo, I guess while you're searching for the slide, for evaluations, I think the top recommendations from Hamel Hussein is roll your own tool, especially for annotation, and that's related to evals. Roll your own tool. And the reason for that is because the application that you know of, you want to do your annotation and evals within the context that is as close as possible to what a real human customer is going to be using it for. And no framework can provide that. Like your application engineers are the ones who can provide that. So rolling out your own tool, even if you're slapping it together with, vibe coding and the likes, that's still going to get you 5 to 7 times faster than relying on duct taping together other frameworks. For monitoring, the most important thing is to log your traces. Log everything. Log a function call, log the response, log the prompt that was sent out, the full system prompt, user prompt, everything. Log absolutely everything that you can from an LLM program. don't skimp on that. And I'm going to pass over back to Hugo.
Yeah, I'll say I agree with all. I do think hand rolling your own tools gets you a certain amount of the way. If you're trying to work with other team members, like having tools that you can all use, it gets very tricky when you're hand rolling a variety of different things. In all honesty, for evaluating and monitoring, there are a lot of tools out there. I love and have used Brain Trust and Phoenix Arise. Logfire's doing incredible stuff. All the Langstar ecosystem. I do, once again, and this is why I brought up this tweet, and this is what I've seen as well. Sam Hogan spent the last 2 weeks with 50 teams building AI apps. Single most consistent thing he heard was, we stopped using frameworks and built our own internally, and it works way better and is easier to use. And this is my point about React as well, right? That we haven't found the right abstractions for building with LLMs. So I do think, in the end, what I see mostly is people using some tools, but then going back to using vanilla Python with API calls, and would very much encourage you all to do that as much as possible. Question up here.
I think on one of the slides, it talked about productionalizing these LLM applications that we'll all go out and build after this. And it briefly said, well, that's sort of out of scope, so we'll not talk about that today. But do you have any, I guess, short recommendations for, approaching productionalization of these and continuously monitoring and improving them over time?
So I think I didn't necessarily talk about tools about that, but I think, let me go back to this. The entire software development lifecycle of building, deploying, monitoring, evaluating, and making sure that you have your tracing, your general observability, your unit tests, versioning, and your monitoring around what's happening here with an ability to iterate using all the techniques we've discussed is the way to do it. I mean, I don't know if your question, there are so many dimensions to this question. So if your question's about load balancing or what cloud provider do I use to do this, or how do I serve 50 or 500 people, I'm not certain.
Yeah, I guess it's mostly just on the continuous monitoring and evaluation. When you're developing it, you're going to be doing a lot more monitoring and evaluation, perhaps. But then, over time, any recommendations on just continuing that sort of indefinitely? Aside from,
I got a response to that.
Yeah, well, I'll also, my
first
first response, I don't mean this flippantly, and I'm happy to dive more into this. If it ain't broke, don't fix it, is my first response. But look at the data, right? So once again, if we go to, these are the principles, right? Know your API calls, work with non-determinism, log, monitor, and trace, evaluate, and iterate. And if you see new types of queries come in that the responses aren't what your users need or what are helping the business, then iterate on the system. And that will often be the case, right? Once it's in production.
We have at Moderna, we have a automatic Git commit message writer that we developed internally, and it uses structured outputs. That one has been subject to iteration. A few people in the system prompt, the original system prompt that I wrote, I said you have to guess the user's intent, right, for the code diffs, and some people didn't like it, and so they started editing out the diffs, and finally someone was fed up enough with the guessed intents, that he made a pull request to the tool and said, I just think we should not have the intents. And then what I did was, I asked him, can you eval by posting a few diffs and then showing that the intents were removed from the generated commit message, and indeed they were. He posted that in GitHub on the comment tracker, and I said, okay, sounds good. But then another dev caught wind of it, and he said, no, actually we need the intents. So then that sparked the whole debate about should we have an LLM guess the intent of the developer as they're making from just the code diff. The solution turned out to be a software-based solution, not a pure prompt solution, which is to have a toggle for whether you want to have the intent guessed at installation time of the tool. So you can like install the tool, and if you're the kind of dev who wants to have the intent guessed all the time, you have to pass it in a flag. And that will install the system prompt with the desire to have that intent guessing present in the commit message. So that's one little microcosm example. There was monitoring, informal, not formal. There was iteration and feedback in the form of like capable devs who understood how to do pull requests. They could make a pull request and just propose the change. And then there was evaluation, informal, not formal, but still getting that one lone dev to go, hey, can you check that the intents are removed from a variety of diffs? So he got creative and he just like got 15 diffs from his commit history, exported them, and then tested them one by one, and that all worked out. So then he was able to prove that over 15 diffs, at least those 15 diffs didn't have any intents. So yeah, that's a little example. But so you'll notice we didn't have any real custom tooling in this case, and it was very informal, but we still adhere to the principles that Hugo's showing up on the screen. There's evaluation, there's iteration, we had informal monitoring, we worked with a non-determinism by like doing 15 prompts, 5 or 15, whatever that number was. We did more than just one, right, to vibe check. And yeah, that was kind of what we ended up doing.
Yeah, and I want to be very clear, like this whole talk has been about the principles that underlie productionizing LM apps. I'm not sure when you heard me say that's out of scope, but it definitely isn't out of scope here. I will add, we haven't covered continuous integration and versioning and like all of those aspects, but to go deeper into those, there are 2 iteration loops, right? One in dev and one in prod, which are connected via CI/CD as well, right? Where you do want to make sure that you're logging everything in dev and prod, and that you have at least something analogous to CI/CD set up. So when you ship changes, you're testing all of those as well, right? And so for those who don't know much about CI, but essentially it's a way to facilitate faster feedback and automating testing with coding changes. And in terms of what type of frameworks to use for this type of stuff, PyTest will get you a really, really long way. So I think that's something to think of there. So we have another question. Oh, we've got one there, and then one here.
So first of all, I just appreciate kind of the optimistic but skeptical view you guys have taken in Eric's talk as well. It's really refreshing. When would you reach for fine-tuning in this iteration process? I haven't heard much about that. I'm just kind of curious, like in the landscape today, when do you reach for that as the next improvement?
Yeah, one place I think it can be very useful is if you want to try to use a smaller model and have lower latency and lower costs, among other things. If you fine-tune a smaller model or even an open weight model on previous conversations, that can really help you get more performance out of a smaller model. In terms of language models, other cases, in all honesty, it's not obvious. There are a lot of cases where people are like, hey, we used to do this with fine-tuning, but you can kind of do it with prompt engineering and system prompting now. So the smaller model case is the main example that I see currently. How about you, Eric?
Yeah, same ideas. Mostly for the highest value comes from fast iteration and not saving on your API call costs. So I would really just say, echoing what Hamel Hussein has said, use a frontier model, use an API provider at the beginning, and only if things really get expensive to the point where it's economically feasible, like to justify doing a fine-tuning run, then do the fine-tuning run. By that time also, because you've probably had lots of logging happening already, you should have enough exhaust pipe of data to actually go and fine-tune a model at that point too. So then like that really sets you up for success for fine-tuning instead. Okay, final question.
Okay, so as a beginner, like in LLM, like building an LLM model, it sounds like a bad idea, to be honest, if to combine all of these different aspects of using an agent, an LLM, and the other various ones. I can't remember off the top of my head, but you as an experienced software engineer, what would you recommend would you recommend to just test them separately and then combine them, or would it just be like not a good idea to like combine them at the same time?
I'm all for like combining everything. When solving a particular business problem, for example, I'd start with the smallest possible unit that you think can solve it, and keep it as simple as possible, and then introduce complexity as needed. That's the best advice I can give. Is there a specific case you're thinking about that we could help with?
I mean, no, not really.
Yeah. So one thing to actually think about is, so I have an LLM with words in, words out, okay? Now, if for my use case do I need memory? Do I need tool calls? Do I need information retrieval? And think about those questions, and then think about, wait, would chaining help me with this? Or would routing? Think about all those anthropic patterns and think about which of those could really help you achieve your goals. And that isn't to say don't like YOLO a lot of stuff as well. Just don't do it like for production business use cases. It's super fun building all of this wonderful stuff. As I said, like vibe coding a Replit Space Invaders game was so much fun. So definitely play around with and experiment with all the tools. But I think when trying to build software that delivers some sort of value, do start small and think about what the smallest composable units are that can help you create that value for yourself and your people. Thank you all for joining the tutorial. I loved all the engagement and all the questions, and very happy to chat over the coming days as well about more of this type of stuff. So thank you once again, and thanks Eric for being a wonderful TA.